Okay, I think we are live. So hello everyone, welcome to GopherCon 2021. My name is Safa and I will be the moderator of today's English session. And yeah, we are so excited for today and we have definitely excited talks today. And before getting into our first talk, I want to give some information about this event. So let's see what I have. So this event will take 2 days. Today there will be presentations and tomorrow there will be workshop sessions. And some of the workshops are free, but for some of them, you must buy tickets. And the tickets are available on Go Turkey community page. And part of the proceeds from the tickets will be donated to charities. So, and secondly, in addition to this English session, we have also a Turkish session, which is currently streaming right now. And so you can check that one as well. And also big thanks to our main sponsor, Trendyol, and our team sponsors, Modernisa and BestCloud for me to sponsoring this event. You can check out the website gophercon.is to look at the open positions of our sponsors. The open positions links of the sponsors are also in the description below. And this stream will be recorded, so you can check the records of the presentations after the event on this YouTube channel. And what else? So lastly, you can check out our GopherCon Turkey Discord channel. You can scan the QR code and on the screen to join our Discord channel. And in the Discord channel, you can reach out our sponsors. And if you have any Go-related questions, you can ask those as well. And also, Discord channel link is in the description as well. And yeah, that's the only information that I have. One last information that our first speaker was Pamir, but he's not here right now. So we will continue with Cem Başaranoğlu at 11:30. So see you guys in 30 minutes. Okay. So hello everyone again. Now we are ready to start. So let's welcome our first speaker. So our first speaker is Cem Başaranoğlu, and Cem is working as a tech lead at Getir, and he will be talking about solving problems using DDD and domain storytelling in Go. Hello, Cem. It's good to see
Hello,
you.
hi everyone. Yeah, thank you. Good to see you too.
So how are you today?
Um, I hope I'm good. I'm really excited, by the way. But
Yeah, we
yes,
are. Yep.
I feel good
Yeah,
for now.
we are all excited for today as well. Now, I don't want to take your time, so you can take it away. Good luck.
Thank you. Hi everyone again. To be honest, I'm really excited because this is the first event that I'm attending as a speaker in this community, and I would like to thank the organizer who contributed to building of this magnificent community and organizing such events. And I can only imagine how difficult it is to organize these events. And so, thank you for all your incredible efforts. And I would also like to thank you for contributing to growth of this community by participating in this event. So, in this session, I will try to explain how we can solve real-world problems using domain-driven design and domain storytelling in Go. I won't be able to dig into domain-driven design and domain storytelling during this session. As you can imagine, these two topics are really tough, and our session time is not enough for this, unfortunately. I will just try to highlight the important points and give you some tips, just give you some tips to you solve any problems as much as I can do. But first, I would like to introduce myself to you again. I'm Cem. I'm working as a technical lead at Getir, and I'm a software craftsman who love design and develop distributed, scalable, reliable, and robust systems. I regularly write technical articles on my Medium page, and also I use Go to build some cool stuff. On the other hand, I love to talk about the software engineering, software design architectural principles, domain-driven design, CQRS, and distributed systems. If you're interested in, you can follow me on Medium. So, in this, I prepared a user story for you, and I will use domain storytelling to visualize the story, and then I will create domain components and share simple codes to accomplish our story. At this point, I have to say that I'm not going to develop very complex codes or design an entire system. And for DDD lovers, I must say, the main purpose of this session is to understand how we can use some disciplines in our domains, and I will make a domain implementation as simple as possible in the coding part. I will not talk about concepts such as checking the immutability of body objects or creating domain-independent aggregate IDs or collecting events on the aggregate and publishing them to a simple broker. And these topics will not be included in this session because as a high level of expertise is required for these topics. Let's say we are part of a team called GeForce, working on Steam, and our team is responsible for the retention domain. Let's assume that our cool friends you can see on the bottom right is our product owner. And suppose that our product owner mentioned that we may offer discounts to some of our customers on the product detail page. And those our customers can have their products they want to buy by paying less money. We can increase our sales, and also we can make a good impact to our customers. Actually, this idea sounds pretty good to me, and generally many teams hash over this idea in their rooming sessions, and these discussions will usually take a very long time, and we will use a 4-step strategy to prevent this and to produce a more robust solution. In the first step, we will analyze our problem with all other stakeholders, and then in the second steps, we will discover our domain and try to create a user story map. And the third step, we will determine our strategy and decide how to communicate with other contexts. And in the last step, we will design our aggregate using the aggregate design canvas, and then I will share some codes with you. And actually, I wanted to implement the code in the last part of the session, but I didn't want to take any risk of not being able to complete this session because, there was a time limit for us, and I need to use my time perfectly. So we need to align with all other stakeholders that are part of this problem and try to understand the problem deeply. You and your teammates may think you have the right solution for this problem, but getting the opinion of all other stakeholders in this problem domain and including them into the solution will make your solution stronger and more accurate. On the other hand, every decision we take regarding the architecture, the code, or the organization has business and user consequences. In order to design, build, to evolve our software systems most effectively, our decisions need to create the optimal business impact, which can only be achieved if we are aligned to business goals, as well as supporting the user current and potential future needs. And badly designed architecture or boundaries can have a negative impact or even make it impossible to achieve these goals. Unfortunately, we have a few options to build this alignment. We can use impact mapping, business model canvas, and product strategy mapping, or worldly mapping, or user story mapping for the business, clarify the business perspective and understand the user vantage point. I prefer to use worldly canvas mapping for this example. As you can see, according to worldly mapping, first of all, we need to declare our purposes. Let's say we have two different purposes for this story. And the first one, to increase our sales and satisfy our customers by offering some discounts. And the second one is to enable our customers to reach more entertainment by paying less money with some different discount mechanics. And after defining a purpose, we need to declare our scope. And in this example, we can declare our scope like as to observe growth metrics by offering some discounts and to track our customers' interactions with our discounts. On the other hand, after the declaration of the scope, we need to focus on the user groups. And we can use three different groups for this example. And the first group contains customers who make the most purchases. And the second groups, customers can have products in their cart for a certain period of time. And the last groups contains first-time buyers or first-time customers. And after declare the user groups or define our boundaries about the users, we need to clarify the user needs. Let's say our user needs show some offers in the product detail page to add some products to their carts. And after the needs declaration, we can design our map diagram. And in the worldly mapping canvas, we have users, we have some user needs, and we have some actions. And we have, as you can see, we have two different actions. The first one is the add to cart, and the second one is the complete the order. We assume that we may increase the add to cart and complete the order actions with using our feature. So, wait a second. Okay. After assuming that we have created such a map with all our stakeholders, we have to discover our domain. And this is the most crucial aspect of domain-driven design. And you cannot skip discovery if your whole team doesn't build up a good understanding of the domain. All software decisions will be misguided. Unfortunately, spreading domain knowledge through the whole team will create a shared understanding, and it enables the developers to build the software systems aligned to the domain, which can be more flexible to incorporate future business changes. On the other hand, ensuring the domain knowledge is spread across the whole team enables its members to contribute with ideas for improving the product. By the way, discovery must be continuous, and teams who are successful with the domain-driven design are practicing discovery techniques and on a frequent basis. And there's always more to learn about the domain. And when first attempting discovery, a facilitator who is experienced with techniques like event storming or user journey mapping can help a team to see the true benefits of discovery beyond the superficial level. We can use domain storytelling and event example mapping and event storming and user journey mapping and user story mapping to discover our domains deeply. I prefer to use the domain storytelling in this session, and basically domain storytelling is a technique for understanding a business domain by relying on people's natural ability to learn a new language by listening to other people speaking that language. And it is also a modeling technique, and it uses a pictographic language with a simple icons for actors and work objects and joined by activity arrows. And the technique is meant to be very simple with almost no technical requirements. And you just need a whiteboard and sticky notes could be enough for this technique. And this allows a storytelling session to begin just by having the right people in the right room, in the same room, and you don't need to learn any modeling tools or any programming language first. Its primary purpose is to transform domain knowledge into business software. This purpose is achieved by bringing together people from different backgrounds or different perspectives and allowing them to learn from each other by telling and visualizing stories. On the other hand, domain storytelling is different from an event storming, and domain stories do not follow a left to right timeline because they need to show cooperation between actors, and that works better with arrows because they show who is doing what with whom, and the arrows are numbered to express a sequence of activities. We called as story. On the other hand, that is another difference is each domain story is about the one scenario. And also domain storytelling tools grouped three different parts. In the first group, describe the actors, and domain stories are told from an actor's perspective, and actors may be a person, a software system, group, or something like that. Hence, we use different pictograms for our actors. On the other hand, we have a work objects, and actors create a work with and exchange work objects and information about work objects such as documents and messages to pictograms represent the work objects medium. And also we use relationships with arrows in the domain storytelling tools. The actors' activities are depicted as arrows. So I want to show you can use Miro or Drawio or other tools to draw your domain storytelling, but I prefer to use the domain modeler. And as you can see, we have a customer actor, and customer actors enters the product page, and then our product page needs the product listing information, and so it's called the product listing system. And also, product listing system is an actor, and product listing system ask to discount engine for available discounts, and they send only the available listings to our discount engine system, and our discount engine system try to build some recommendation and offers based on these listings. But our discount engine, as you can see, doesn't have any idea about the client or other segments or other product information. So it must be fetch client information and product information first, and then it must be built its own domain logic with using this information. So first of all, our discount engine call the client management system with using client ID, and our client management system is another actor in our ecosystem, and it responds the segments to our discount engine again. After that, our discount engine system needs to know the product information data, because our product listing system it just store simple projections. So our engine calls to our product management system, and it's another actor in our environment, and then it responds products to our discount engine. And after that, our discount engine applies some business logics and to build some offers for our clients and responds to available discounts to our product listing actor. And then our product listing actor builds some offer with product discount information and send this offer to our customers. This is the simple implementation or explanation of the domain storytelling technique in our domain problem. So I can share presentation again. Okay. After the discover our domain, we need to apply the strategic architecture and decide the strategic design patterns. In fact, strategic design is the most important step of domain-driven design. It offers some techniques for describing your domain and its components, and it contains ubiquitous language, bounded context, context map, and core domain concepts. And we can define bounded context as a region of the application where consistent behavior is expected. One region of the application may require a client, in example, and with birthday information and name, and while another region may only care about the client name. It's important to keep these regions separate to preserve consistent behavior and conceptual integrity. Frederick Brooks talked a lot about this concept in his book, The Mythical Man of the Mount. On the other hand, any given model is only applicable within a context, and it should remain consistent within that context. The context-model relationship should be explicitly defined. On the other hand, bounded context, they always refer to separate solutions, but definitely separate areas of a solutions. And each context ideally has its own team or structure, but this is not terribly common in the real world, and it's good to keep the separation mentally at least. Also, we try to build our ubiquitous language to decide our strategic architecture. Ubiquitous language refers to all the terms and their definitions being used in the project. One of the great advantages of the ubiquitous language is to bring together the domain experts and the technical team and the other involved in the project. By the way, ubiquitous language should never be a set of terms or technical jargons imposed by domain experts or technical leads. On the contrary, a ubiquitous language is developed in agreement of the whole team. And the ubiquitous language must be spoken at all times between the team members and expressed in a software model. This actually causes us to establish a communication bridge between the technical peoples or problem space and the solution space. On the other hand, we need to know the subdomain concept to define our domain objects. And basically, subdomain is to problem space as bounded context is to a solution space. Subdomain is abstracted to the level of the problem, and while bounded context is not as abstracted because it's at the level of the solution. Sometimes bounded context is shaped to fit the subdomain, sometimes not. The latter is often the case in some legacy codes. And strategic patterns are focused on integrating bounded contexts, which are logical boundaries in our systems. When the problem space is defined with domains and subdomains, it's time to implement the architecture or teams that will take care of the solution space. And bounded contexts define a common language or model within a subdomain. And usually, when the language or model being changing its meaning, it means the another bounded context can create. I prefer to use core domain charts to build my strategic architecture design, and it helps you to visualize the strategic importance of each subdomain or business capability in your architecture, allowing you to make business model aligned architectural decisions. And as you can see, we have core, supporting, and generic domains in our graph, and we have two different domain objects in our core context, and these are discount and offer domains. And our discount and offer domains bind it together with a collaboration topology. On the other hand, we need to product and client information. So we assume that there are different teams, and we bind this teams with using the X as a service topology. So maybe we can use some localization domains to localize our messages. So localization or configuration or something like that is represent a generic domain context. So, and after declare our domain objects, we need to decide our context maps. And in fact, to visualize how different bounded contexts interact, DDD has a general purpose technique or tools called context mapping. And when creating a context map, it's possible to identify potentially logical boundaries in a system. And strategic patterns work by specifically integrating those different bounded contexts. Also, we can define the context mapping as the simplest way to identify relationships between bounded contexts is to classify the context as the upstream contexts and the downstream contexts. As you can see, we have two different main contexts. The first one is the discount context, and the second one is the offer context. I prefer to use the partnership context map to bind this, to build a relationship with this different contexts, because the teams of both contexts cooperate, and the interface evolve so that they accommodate the development needs to both contexts. And independently features are properly planned and scheduled so that they cause as little harm as possible to both teams. On the other hand, I prefer to use the open host context mapping to bind product, client, and localization contexts to our base or core domains, because open host service access to a system and is provided by clearly defined services using a clearly defined protocol, and the protocol is open so that anyone who needs to can integrate with this system. Web services or microservices are a good example of this integration pattern. And the key when using this pattern is to keep the protocol simple and stable. And as you can see, our discount context and bound offer context is upper bound contexts, and localization, client, and product contexts are downstream contexts. So after the modeling our context mapping, we need to focus on the aggregate design. And I prefer to use the aggregate design canvas to build, to design my aggregate, because it's a modeling tool meant to be used as a part of a design level domain modeling activities. An aggregate is a lifecycle pattern originally defined by Eric Evans, and by aggregate, we understand a graph of objects that is a consistency boundary for our domain policies. Depending on the design of the aggregate, we can either enforce them or be forced to have corrective policies in place. Because of that, it's important to design the boundaries of aggregates well, as they impact behaviors modeled within our domain. This canvas has suggested orders of working through it, and that helps to iteratively discuss different aspects of the aggregate design. So as you can see, I just set a name for my aggregate like offer, and I added some description for my aggregate. I just add some roughly throughput and size, and also I just add enforcement invariants. For example, discount is calculated only for segments 1, 2, and 3. On the other hand, I don't have any corrective policies. I don't have any state transitions like opened, closed, or frozen, something like that. And I don't have any created event like product created, order created, or other stuff. I just have only one command for this example. I just try to handle the make and offer commands. Okay. After the technical, before the technical architecture, I need to clarify some buzzwords about the domain-driven design. And first of all, we need to understand the aggregates. And aggregates are a set of entities and value objects that change together. And every aggregate has an aggregate root, which is the parent of all objects in the aggregate. This root can be determined by asking some question like, if I delete this member of the aggregate, do I need to delete the others? And it means cascading delete. And if the answer is yes, that object is the root. For example, if a person object gets rid of its phone number, okay, this is not a cause for deletion of the person. But if the person is deleted, the phone number, if the person is deleted, the phone number should also be deleted. So person is the root. We can say the person is the root. And an indirectional relationship between the root and other objects in the aggregate should run from the root to the other objects. The root can reference to the other objects, and only the root can reference those objects. And this is the important part of an aggregate. You can also have an aggregate that only contains one object, and data changes to an aggregate should be atomic and consist and is isolated and durable. And we need to know the invariants. Invariant is the most important part of the tactical design, and it means rules in an application that must be followed in order for the model to be validated. A real-world example would be the speed of the light. The aggregate root should be responsible for enforcing invariants. On the other hand, we use a repository, and repository controls data access in order to maintain consistency. It is responsible for object persistence. And a repository's interface should be an illusion of a collection, according to Julia Lerman. And it also provides methods for common queries, and we need to keep code dry in this layer. Also, repositories should be provided on the aggregate roots. We don't use repositories for value object or something like that. And also, we need to know the value object. An object whose identity is defined by the values, its properties. It must be immutable, by the way. On the other hand, we need to know the entity and object whose identity is based on continuity of identity and which is not defined by its value. So after the explanation of this basic concepts, we can check our code implementation together. So as you can see, we have two different aggregates, an offer and discount, based on our core domain chart. And our offer aggregates have ID, segments, and other properties to build its own domain logics. We hold and manage all offer domain logics in here. And as you can see in our core domain charts, we need to know the product and client. And I defined our products and clients as an entity. We have a client, and we have a client, as you can see, but we need to enrich the client to build our domain object. So we need to access the client service directly in our domain object. So I just declare some service adapter to access the client service, and then as you can see, wait a second. Okay, I just show that in here. We have some interface to represent the client service behaviors, and I just added the get by ID function to fetch some client from the client service. And we have some client contract and product contract, and it's different. These are different from our domain object because our bounded context behaviors can be changed, but we need to define and we need to ensure our domain object in our aggregate. So we convert our contracts to our domain objects in our domain. So when we need to build some clients, we just call the client service with some HTTP port or HTTP protocol or something like that, and just validate our client object, and then just mapping our client object, client contract with our own domain object. And we need to make sure our objects must be safe in our domain aggregate. On the other hand, I declare some product object to build our business logics in our domain aggregate. And I use domain service adapter like client service to fetch product information from the other domain, other subdomain, which name is product. And we try to fetch product information from the product actor with using HTTP call, and then just try to map this object to our own aggregate. And after that, like I said, we have a discount aggregate. And as I said earlier, discount and offer domains are the same, and we use collaboration for this domain, and we prefer the partnership as a context map. And so we just call the domains discount aggregate with using the discount repository, and we just find the optimal discount by product ID, and our discount aggregate just return the optimal discount from their own database to us to build some offer to our customers. So when we try to create a new offer, we need to pass client, product, and discount object to our aggregate. And for this, we have some adapters to access our bounded contexts or subdomains. And I just create some simple query objects like make and offer query. I just add client ID and product ID to my query, and then I just try to handle this query in my domain, in my aggregates, and to offer any discount to my customers, I need to know the client. So first of all, I need to try to ensure the client informations, and with building a new client in our aggregate, in my aggregate, and then I try to build product object, product entity with using product service adapter, and then I just call the discount repository to find optimal discount with my product ID. And after that, I just apply some business logic. And first of all, I check this segment. Client must have a segment to see any offer from my side. And also, I just check client segments are matching or not our defined segments, because in our assumptions we aligned and discussed only the three different segments to this feature. So if our client segment matched the defined segment, we just calculate the simple discount and apply this discount amount to our another aggregate object. we can use optimal discount as a value object because we don't have any identifier and we don't have any identity property for our objects, and it's immutable and it's changed when the dependent properties change. And if the discount amount calculated and changed the optimal discount, I just return the offer. But in this part, I prefer to use the clean architecture. I just create some folder structure like application, domain, and infrastructure. I don't have any API layer for now. And I just return an offer, but I need to access an offer in my application layer. So I just create and make an offer query handler to capture this make an offer query and start to build my own business logics. So I just declare some query handler and I just pass the relevant boundaries or dependencies to my handler with using some constructor function. And then I just append a handle function to listen this event. I prefer to use the mediator to handle these events. If any events occurred, I just capture this event and try to convert this message to my query. On the other hand, I just try to fetch all offers from the database, and then if any offers fetched from the database, I just apply my domain logic in my handler, in my application layer, and then I just convert my domain object to my contracts, because I don't I can't share my domain directly to my API layer or my clients. I just use some contracts to abstract my domain from the other components. So I prefer to use the assembler pattern as the enables to convert some objects to another object. And in this part, I will just convert my offers to my contract with using the assembler patterns. And then I just want to show an offer contract to you. And as you can see, I just have an ID, discounted price, and price properties in my contract, but my aggregate is different from that. My aggregate is enriched object and have lots of properties, but I don't want to share my business logics or expose my business logics to my clients. So I must use some contract mapping to prevent expose the business logics to my clients. And I don't have any API layer because this concept is based on the domain design. And I think that's from me. If you have any question, I'll try to answer that.
Okay, that was great, Cem. I think there is no question, but if you have any questions, Cem will be online in our GopherCon Turkey Discord channel, and the Discord channel description in below, so you can scan the QR code.
I can continue with Discord channel, but I want to answer the Mustafa's question. Actually, no. DDD is not a silver bullet, and it's not a one-size-fits-all solution, and it's really complex and tough, I think. If you have a simple or lightweight project, please don't use the domain-driven design. You're welcome.
Okay.
Okay.
See what else. I think there's no question.
Okay.
Yeah.
Thank you for all. Take care of yourself. Bye-bye.
Thank you, Cem, for your time and presentation. See you next time.
Bye-bye.
Okay, so the presentation will be at 12:30. So we are giving like 20 minutes break. So see you at 12:30. Okay, we are back again. So our next speaker is Kemal Akkoyun. Kemal is working as a software engineer at Polar Signals, and he will be talking about profiling Go applications in cloud-native era. So let's welcome him. Hi, Kemal. How
Hello,
are you today?
everyone. I'm all right. How are you? How is the conference going?
Yeah. Well, it's going pretty fine, and yeah, we are so excited for your presentation as well. Now, I don't want to take your time, so you can take it away. Good luck.
Great. All right. As they mentioned, my name is Kemal, and today I'm going to talk about profiling Go in the cloud native era. But like before we start, maybe I just introduce myself. I'm a senior software engineer at Polar Signals. It's a small startup. We just found that, and I recently joined that company. Before, I was working for Red Hat, and I was building observability tools for Red Hat infrastructure. I'm an open source maintainer. I've been working in infrastructure area for the past 4 years, and I've been building tools with Golang. And for 3 of those 4 years, I mostly focused on the observability tooling. So I'm a maintainer of Thanos project. Maybe you know about it. It's a metrics collection tool. It's actually you can think of as a extension to Prometheus to store long-time retention metrics. And I'm also recently became a Prometheus client Golang maintainer. As like today we're going to talk about continuous profiling. We are building another tool, open source tool called Parka. I'm also a maintainer of that. You can find all the slides after the talk under those links. I'm going to be tweeting about it, or you can just check my webpage and access to those. So let's start. First, before we jump into continuous profiling or like profiling in the cloud native area, let's talk about profiling. What is it? It's an old concept. I guess the first appearance of is around 1970s. It's like it's old as programming. So when it comes to what, it's a form of dynamic program analysis, right? It's an act of actually checking out the processes that's run on a system and like measuring the resource usages of all those processes and the systems. To be able to do the profiling, we have actually 2 ways to do that. One is tracing, which is tracking all the events that is happening on the system. And then from those records, just like gathering out all the necessary bits and pieces. It's a highly cost operation and like it's hard to enable for the processes each and every time. The other way is sampling-based profiling, which is rather than like collecting all the events that's happening on the system, you just like in a periodical interval, just like check out the processes and check their resource usages and record that, aggregate that, and then store it somewhere else. There is an actually, you can call it a blog post or a white paper from Google, where they measured with their infrastructure and they observed that that's actually really low overhead per CPU, per process CPU usage and memory usage. This is the way that we actually profile the programs, and we also have types of profiles, right? From a process, we can collect the CPU usages, we can collect allocations, we can check out the memory, what's going on, and we can also check the I/O operations, what does that certain process actually do in the running host. But why? Like, why we are doing this? Why the hassle, right? Because first of all, we want to improve performance. Because like as reliability, performance also matters, and we want to achieve, for example, if you have a web service and you want to increase your SLOs and you want to just decrease your latencies, you need to be aware of what's going on under the hood with your system, and so that you can provide a smooth user experience to all your users. The second major factor is actually saving the money, cutting the costs, right? Like everything we run nowadays is running on cloud. That's why as in the title, cloud native profiling, right? And all the cloud providers usually charge by the hour or by the usage of the resources. And if we can just reduce the resource consumption, that is just saving money, cutting the costs. We actually observed yes, this is not a scientific number, but from our interviews with the many organizations, we can observe that you can actually cut 20 to 30% of the resource usages and from their use paths, and you can provide like lower cloud bills, right? So how to actually profile Go programs? Probably some of you are already familiar with. It's not a news because we have embedded profiling tools in the Go runtime itself, and which is actually pprof, and it's a descendant of Google Performance Tool Suite, which is actually, I guess, built for C++. Then it's converted to the other languages, and since the Golang itself is coming from Google, they already built everything related to pprof in the runtime itself, and it's very well supported. We will talk about this. So why pprof is actually important for us, for the community, because it's an open format, and there is already lots of adoption around it. There are supports from other languages, other runtimes, and there are actually built-in tools that actually can consume pprof data format. They can visualize it, or they can directly ingest in their systems, right? So it's very well adapted. That's why it's actually beneficial for us, because then we can mix and match with the different runtimes and with the different workloads in our infrastructure when we just like converge on the open standards. That's why using pprof actually is a big win for us. So how does it look like? You can see here, it's a protobuf format, and it's optimized to consume less space, or like save cost in the wire. And in this chart, you can see that there are a couple of concepts, bits and details, but actually it's not like very concerning for our talk today. So what support do we have with other languages and Go itself as well? So basically, we have the CPU support for all the known runtimes for the pprof, right? This is JVM, Node.js, Python, Rust, and Go. But Go has also a special case because, like, inherently, it's already integrated in the runtime itself. We have allocation support, blocking support, and we can actually check out mutex contention, and we have specific profiling tools around Go routines as well. So how does it look like? Say that we have a code in the left-hand side. It's just like a simple format. There are a couple of iterations, but like they're taking too much time, even though they're not doing anything. This is just for example's sake. We can represent that program whenever we profile, as we see in the right-hand side. This format called a folded stack trace format. It's from Brandon Gregg. It's easier to read for the humans. That's why I'm giving an example here to show you guys. So you can see that each program in a hierarchical manner calls another function, and we represent all those function names as in the folded stack trace format. So that same folded stack trace format is represented with pprof, as you can see in the right-hand side. It's just like aggregation of those things, and we have the location IDs that correspond to those function names, and the values are actually number of times that we encounter to that stack trace. that's actually how it works with the pprof when you consider the CPU profiling. Okay, we have that. We are already like running our program, but how we can actually expose those profiling data from our Go applications, right? As I mentioned a couple of times, pprof is integrated in the Go runtime itself, and we have some nice packages around it. We can just import a NetHTTP pprof package, and in that we have readily available endpoints where we can just like hook into our middlewares, and we can just like serve them from a certain path, right? So then what happens next, right? So in the Go tool itself, or you can also run the pprof separately from the Go tool, you can actually visit those endpoints and gather all those data. For each endpoint, that is like whenever you hit that endpoint, it records the profile corresponding to that endpoint, and then it gives you a gzipped profile format, right? And then the Go tool actually can understand and just like visualize that. So when it comes to visualization, it's something like that. It's not one-to-one correspondence with the code piece, but this is the UI, and you can select different visualization methods and check out what's going on in your profiles, right? This is called flame graph, and we have another format called like call graphs. This is where you can actually see where like hierarchically where does all your program components, functions, or you may say locations actually represented. And in this graph also the sizes of the box actually tells you that how much time you spend on those specific node. So this is how you actually check out a running process and profile a running process, right? You just hit those endpoints, download that profiles, and check out with a pprof tool or any other visualization tool. So like this is incredible. We can do a lot of things, but as I mentioned, it's a little bit involved process, right? You need to instrument your application. You need to hit those endpoints, download that profiling data, and then investigate. So the problems is in the process itself, right? It's momentarily. So you need to hit those endpoints to catch like what's going on actually in that point of time in your process. And it's a manual process. It's not automated with the tools that we have already. If you want to automate that, or like say that you observe something that spikes the CPU usage using your metric system, maybe you have dashboards and you check your dashboards and there's something going on there in the process A, and then you just like, you already put those endpoints in there and you just need to curl or maybe use another script that you already built and download the profile and check it out, right? So it's like homebrew workflows basically, and it's so manual. And one of the problems is you need to do this ad hoc manner. So you cannot actually determine like what's going on before that actually some incident happens, right? So there is where the continuous profiling actually comes in. Continuous profiling is just hitting, you can think of that like in a given interval with a period of time, you just like go and visit and profile your processes and store them somewhere else, right? This idea is like widely popularized by Google with this paper. And they are, in this paper, they are actually telling us about how they continuously profile their infrastructure for each and every process. And how they actually optimize on a rolling manner. So, but why, right? It's as always. So why do we do this continuous profiling, and why do we try to do this maybe in production? Because first of all, development isn't your production. So maybe you're running a process and in your laptop and you discover something, you're debugging it, but like the resources, the hardware is not same as in your production systems. Moreover, probably you're like maybe running some Mac OS and running your Go application in there, and then like you're deploying in a totally different environment. Yes, with the Dockerized environments, we are kind of like closing that gap, but still the underlying software is matters, right? And the other thing is actually you cannot probably mimic the exact same load that you have in your production cluster. So doing this in a continuous manner is totally different than what you have in your development environment. We already talked about like pragmatic issues of continuous profiling and where we actually came here, and like we discussed about the production versus development, but there's also like there's a really good aspect of continuous profiling with emphasis in continuous, right? Like doing this continuously, checking out the data, you can actually put everything in a context over time, and you can then introspect your infrastructure as a whole, and maybe you can correlate with your other signals, observability signals, to actually find out what's going on your infrastructure or program. So again, when it's useful, we actually like iterated over this like couple of times. Like it's about saving money, understanding the differences between maybe our versions, maybe our like specific use cases of the same program, and also understanding about the incidents, what's going on. With enabling this data continuously, you can actually query later on and check out and actually answer all these questions. So let's give an example. This is somewhat familiar pattern maybe for anyone that actually runs their system on Go. This is a memory usage pattern, and this is called tooth solve pattern, right? We see that a process is actually running and hitting a memory limit. A process continuously running and it keeps allocating memory, and then it hits a limit and the process just restarts and it spawns another process, which is an out of memory kill, right? This is really a common thing with, even though we have a garbage collected environment with the automated memory management, we still can have leaks, and these leaks can end out of memory kills of our process, even with the modern infrastructure. What the modern infrastructure actually gives us just like ability to self-healing processes, right? They just restarts, okay, we have a new process and our system goes on to work. But if this happens like pretty frequently, that means, I mean, there's something wrong with your system, and there is no easy way to tell actually with your existing observability signals how to just like pinpoint this, right? Because you cannot actually find out what's going on exactly before that kill happened. Metric doesn't give that information. Maybe you have a logging system, then you need to do this manually to understand like what's going on with the logging, and this is a lot of investigation. There is no easy way to do that. So this is a solution, like this is the solution or like claim as a solution of continuous profiling to these certain types of problems. So, but how we do this? Like in a simple manner, what we can do is we have already instrumented or our applications, or maybe we just add those endpoints into our Go processes. And pprof creates profile samples for us, and every so often we just go to that process and check those things. It's still have little overhead, and we get those profiles, and we hope that that happens before the kill, and then we just store them somewhere. We can just automate this workflow, right? And by automating this, we can index the same data and query that time. That's like get this, hit those endpoints, collect the data, store them somewhere else, index the data, and then provide a query engine to read those indexes and fetch the data itself, and provide a user experience that you can actually find out what's going on with your program. So how it like looks like underneath is we just like hitting those endpoints, and sometimes we have gaps. Maybe we don't have that profile because we have a different period for those certain profiles, but we collect those over time and we just like store them and then we will we need a way to actually make them queryable, right? This is like more or less like from profiling to continuous profiling, how it works. But the gist of this thing is we can actually run like a profiling system continuously on our production servers with the same hardware, with the same software, and we can detect any incidents. We can do post hoc analysis for each incident. We can check what's the resource usages, or we can check a snapshot of that process, what's going on before that actual incident happened. So and there is another thing that's happening in the community, which is a bright new feature. With the continuous profiling, we can actually enable a different type of optimization path called profile-guided optimization. This is a known technique, and like this is already enabled with the JVM. If you are using GraalVM, there is a head of compilation strategy where you can actually record what's going on in your Java infrastructure and dump a profile. Then from that profile, you can actually feed that to a GraalVM and ahead of compile and optimize your programs. The nice thing about this is coming to Go as well. So there is an ongoing PR, which is actually discussed with 1.17. But if you read the PR comments, they already said that this won't be happening anytime soon. But they want to share this code base. This is contributed by Uber people, and they are like in discussion with the Go team. And this will land in Golang in a couple of versions. That means we can actually feed our pprof profiles to our Go compiler, and Go compiler reading that profile can optimize our hot paths, and maybe it can decide to inline or allocate less memory. This will be doable in the future. And that means you can actually, having a continuous profiling system, you can optimize your build pipelines, your CI pipelines, right? You can run the systems, and then you can get a dump from your continuous profiling system, and then you can feed that and recompile your binaries with an optimized version, and you can just like redeploy this to your cloud infrastructure. And by that way, you will have just like, without having any human in the loop, you can have optimized build processes, and you can increase your performance, or maybe you can cut the cost. Maybe this is not the huge win, this automated process. Maybe it will be just 5% and 10%. But if you are actually running thousands of containers that running Go programs, that actually makes a lot of difference. So that where comes the Parka is. Parka is an open source continuous profiling project, which is contributed to community by Polar Signals, the company that I'm working for. This is like, it's Apache license, and it's like you can just use it. There is no catch to it, and we do everything is open because we are true believers of the open source. So we concentrate all our efforts to improve the Parka. So how does Parka actually look like as an architectural manner? There's an agent, we're gonna come to that, or we can read directly from the HTTP endpoint from the pprof that's serving. We already talked about that. That is Parka server then can just like store them, index them, and make it. There is also a UI, an API that exposes those data, and a way to actually query that data. All things going to be stored in the object store because we believe that is a way to cut the cost. It's easy to integrate with object storages, and it's like they're cost effective, and their API and availability is so high. Also, since the Parka is like written by the Prometheus maintainers, we have a couple of Prometheus maintainers in our team. We share the same service discovery and same mentality with the Prometheus itself. So As I already told, it's an open source project. Even though Polar Signals is the creator, we have a neutral governance organization model. So we are looking for more contributors. It's a brand new project. And if you're interested, just hoping to ship. And it's like a fast track to being a maintainer of a cloud native project. As I told you, it's inspired by Prometheus, singly statically linked binary, multi-dimensional label model, and so the same service discovery and similar built-in storage. But there is also an additional offering from the Parka itself, as we already show, like with the pprof, you can enable those endpoints, and that's a way to instrument your code. But you can skip this step with using Parka. eBPF is a brand new technology where you can actually write programs to run in the kernel space. And by running those things, you can actually build observability and monitoring tools around the for each process that's running on the same host, right? That means zero instrumentation. You don't need to do anything. You just like install the Parka agent to running host, which is easily integratable with your Kubernetes clusters as well. And then Parka agent does the rest, like discovers the processes of the C groups that you want to collect. You can filter them out, like which process do you want to attach the agent to, collect everything, and the collected binaries will be converted to necessary pprof format and ingested by the Parka agent itself. So as I'm skipping the slides ahead and like talking the same thing, the same points over and over again, but yes, it uses eBPF, discovers the C group of the current system, captures the stack trace. We only have the CPU support for now for the agent, but we are working on extending the support with the other type of profiles as well. And then you got everything and send them over to Parka agent. Every communication's in gRPC, so it's like wire optimized. This is a high-level overview of how Profiler actually works. If you're interested, you can check out the slides later, but it's going too deep for this presentation, maybe. So visualization. We collected the data and we are storing that. So what's next? The actual things matters is the user experience, to understand what's going on in the hood in our infrastructure, right? This is the Parka UI, where your life is actually start by selecting the type of the profile you want to check. The process CPU samples is coming from the eBPF, and the rest is coming from the embedded pprof endpoints. So this is an example of Go profiler, Go process profiles. And since Go runtime already provides like different ways of doing this, all of these is enabled for you. Yes, there's two ingestion methods. One is pool-based, where Parka can visit all those endpoints and collect this high granular data, and the easy integration way just for CPUs right now, but you can always mix and match them. There's a way to filter a query language or profiles, and you can just filter by the labels, external labels that you have on your running system to describe your workloads itself. So what happens actually, you select, for example, one of those profiles. This is the view that you get. You see the profiles over time, and you can click any time in the space and check that profile, and you will be getting an icicle graph. It's a different form of flame graph, and you can just check where your actual process is spending the time, or memory in this specific case. So one nice thing about this, you can actually merge the profiles over time. You can actually select for the last 5 minutes or for the last hour, please just aggregate everything and show me what's going on in my process, which is useful because you can then compare them, right? You can say that, okay, I'm seeing a spike and what's actually happened before that point of time and after that point of time, and compare those profiles and see actually like which function or which program down to line number is allocating more memory or more spending more time on the CPU. You can actually see that. Since there's a query language and a label support, you can actually, by selecting certain labels, you can find out and like dive in what's going on depending on your needs. So all these demos interactively and available for you, demo.parko.dev. Just go and see it for yourself. So we also like implemented the storage from scratch because we needed something better for the time series data that we have. It's inspired from Prometheus itself. It's separating metadata, redundant data from the profiles itself, and it's using different chunk formats. As I told you, like it's all open source. It's project written in Go, and if you want to learn about the time series database internals, it's a nice candidate to actually check out this project. So this is how it looks like as a Go struct. I'm just like skipping and increasing the pace a little bit here because I'm running out of time. And this is like how we actually create meta store entries, which we just like get the same profile and put them in a relational format. We recently changed those bits. It was a SQLite in-memory database, but we are using Badger right now. We observed that it's performing better. By the way, by meta store information, I mean I am like talking about the human readable strings, for example, function names, the source information, those type of stuff. What we get from the profiles, just the raw memory addresses, and we need to translate those memory addresses to actually human readable format, and this is how we store those information. So this is how it looks like as a whole profile. We get some samples, those observations for corresponding locations and the values of those, and then we store them in our like newly created TSDB. This is the architecture of that database. If you're interested, slides will be available, and you can also find that in our website, parko.dev. This is actually what we are. This is the new thing that we are offering on top of Prometheus TSDB. We have different type of data, and depending on those data types, we are using different encodings, because in the profiling data can be sparse and maybe the values are not changing that much. And with the existing Prometheus representation, it's taking much more space. But with this new advancement, we can actually be more space efficient. So how querying looks like, we show the user interface, but this is the query, what's going on under the hood with the queries. It's very similar to PromQL. You can just like add the labels and the name of the profiles, and you can then get the profiles what you need. It's all in proto format with the gRPC, very efficient. Even the communication between UI and the backend, it's in gRPC. And because the amount of data is like so large, this is also heavily optimized. Under the hood, these are the data structures, or how those like proto-buff representations look like while we compare the profiles. Actually, it's just like simply like with the same stack trace, the same locations, you have a value, and just like subtract that value, and just depending on that value, render the whatever we have. Same goes for the merging profiles, simple math. Since this is an aggregative data, this type of approach is like easy to do. So Parka's roadmap, we want to persist everything on the disk so that we can provide long-term retention. We are still working on that. We also want you to query parts of the stacks only. So if you want to track a single function method name, for example, we want to make this enabled for you. And we are constantly working on improving language support. This is not for just Go. Any compiled binary or language is actually supported right now. But when it comes to dynamically runtime languages like Python and Ruby, it's a little bit tricky. With digital languages like JVM, Erlang, or some part of Python, we also have the support, but we are constantly working to increase the language support, because we know that in the infrastructure, you are not running only Go, lots of other programs, and we want to just like also provide that information so that you can, maybe you have a microservice architecture and you can have a holistic picture of what's going on in infrastructure. Maybe if I haven't mentioned, we are not just like with the agent approach. We are not just providing what's going on in your process. We are also giving all the calls to the syscalls and everything what's going on in the kernel itself, because the eBPF programs can run in the kernel space. We also provide data, and it's the whole stack that you get from us. Additionally, we are working on heap and allocation profiling. But most importantly, we need to build a community. We need users, and this is where you come in, right? Like, this is an open source project. Please use that. Try your infrastructure and give us feedback. If you're interested in developing TSDB storages or observability infrastructure, we are the contributors, and the maintainers are always welcome. Come join us and say hi. We have a Discord channel. You can find that in the parka.dev website as well. With that, thank you for listening. And if you have any questions, I'm here.
Okay, that was great, Kemal. Let's see, we have questions or not. I don't see actually any question right now, but if anyone has any question, where they should reach out to you, Kemal?
I have a Twitter account. You can always reach out to me. If you want to chat, as I told you, I'm also hanging a lot in Discord recently. You can find me in Slack, any of the CNCF communities, Gopher Slack, Discord. Come say hi in our parka.dev Discord as well. So I'm like pretty much reachable. So just like type my name and you will probably find the information you need.
Yeah, yep, that is great. So yeah, thank you, Kemal, for your time and your presentation. Hopefully see you next time again. And take care.
Yeah, thanks for inviting me.
Always. Okay, so our next presentation will be at 2 o'clock. So now we are giving what time? So like 15 minutes break. And so see you at 2 o'clock again. Okay, now we are ready for the second part of our English session. So our next speaker is Hüseyin Babal. Hüseyin is working as a senior software engineer at Hazelcast, and he will be talking about how to maintain open source Go projects. And let's welcome him. Hi, Hüseyin, how are you?
Hi, thanks, Safa. What about you?
I'm pretty fine, and yeah, we are so excited for your talk. And now I don't want to take your time. If you can share your screen, I can leave the stage for you.
Okay.
By the way, when you are preparing your screen, I can give some information about our Discord channel. So we have a GopherCon Turkey Discord channel. So if you want to reach out our sponsors, you can join our Discord channel, and also you can ask your questions in this GopherCon Turkey Discord channel to our speakers and also our sponsors. So there are also open positions of our sponsors. And you can also look at the open positions of our sponsors by in this Discord channel. And yeah, so you can scan that QR code right now in the screen. And also we will have tomorrow, there will be like workshop sessions. And for the workshop sessions, you can buy tickets on Go Turkey community page. And you can also scan this QR code in the screen right now, as you can see. And yeah, are you ready, Hüseyin? Okay, I think we are having a problem right now on Hüseyin's. We will. Okay, right now Hüseyin is trying to connect again. Let's see him. Let's wait him. Okay.
So it says Chrome has lost permission, but
okay, if there is a problem, we can give a 5 or 10 minute break, and when we are like, okay, cool. So yeah, so until we
5
solve
minutes
the problem,
is okay, I think, because I will
like
recap everything.
Okay, we are giving 5 minute break. We will hear after like 5 minutes. Yep, see you guys. Okay, we are back again. I am adding Hüseyin again. Okay, I think we are ready right now, right?
Yep.
Okay, I'm just leaving the stage to you. So good luck with that.
So sorry for the delay, by the way. Thank you all for coming to this session. So my name is Hüseyin. In this session, I will provide to you a set of best practices about how to maintain open source Go projects. So here, whatever you see, they are all applicable to other languages, but the examples, they are specifically provided in Go. Examples are in Go. But you are free to apply these methodologies in any kind of other languages. Of course, not something like assembly or some other languages, but you can apply to some modern languages. First of all, I would like to start with I am really happy to use GitHub, GitLab, and Bitbucket because they really enable the developer ecosystem in a way that we will collaborate in good projects, right? So open source project, open source world, always there before the GitHub, but they somehow shape this world and put into very good situation. And so you have a project, lots of people, lots of contributors working on that. That's a very cool thing, but of course it has some kind of drawbacks. First of all, you need to introduce some kind of rules in order to keep this project quality on track. In this session, we will mostly see how to do that, how to automate this process. First of all, let's start with Go project structure. I will not deep dive into Go internals because if you want to see the Go internals at the end of the session, I will provide a link and you can see the session titled by Fast Track to Golang Development. You can see all the best practices there. But here, I assume that you have a project, open source project. It is a modular project, which is called, you can do that with Go modules. In order to create a modular project, you can do go mod init and provide your version control system URL. Here, it can be GitHub, GitLab, or Bitbucket, whatever you want. When you do that, you will see it will generate a mod file, go.mod. It is really same with, the notation is same, similar with Node.js and npm init. It creates a package JSON. It contains some kind of metadata, version, dependencies. Same strategy is here. When you have a look at the details in Go mod file, you will see the module name, actually the URL, and the Go version that is used to build, compile for this project. And also you can see the dependencies. Dependencies are stated by using require keyword. In require keyword, you can use one or multiple dependencies. In my case, I am using Go SDK for GitHub APIs, and that's it. So again, in order to see your dependencies, for example, in Java, if you are using Maven, you can just create a tree by using Maven dependency tree and output it to a file. You will see the hierarchy of the dependencies. Here, there is same strategy. You can list the dependencies. Of course, these dependencies can be direct and indirect dependencies. In my case, I only use Go GitHub, but you see there are 10 more dependencies because Go GitHub just relays on the other packages that are not indirect dependencies for me. So using Go module project, Go module system will be a plus for you. It will be a plus for your start. Okay. PRs are very important in this kind of community project. If it is an open source project, most probably you will use a PR notation, GitHub PR flow. If you are inside your how can I say that, in your company, for the internal projects, you can use maybe trunk-based development. But here in the community, using the GitHub PR flow will be best because it is the quality gate for your project. Let's say that you have an idea. There is a feature needs to be implemented. You fire a feature branch, you implement your stuff, whatever the feature it is, you push the remote, and you create a PR, right? When you create this PR, there should be some kind of set of checks inside this PR to understand that, okay, I am on track with my quality, everything works. If you added new features, then you need to cover that new lines And based on this information, you can see that there are three categories in this kind of PR checks. First one, linters, vulnerability checks, and the code coverage. Linters is something like help you to keep your code base as qualified as possible. And you can use linter libraries, for example, GoVet, AirCheck, StructCheck, VARCheck, for example, this kind of dead code. There are this kind of libraries. You can use them independently. Or there is a better option, which is Golang CI lint. This is the complete orchestrator of different kind of linters. So instead of using linters separately, I mean trying to download them separately, you can use Golang CI lint, provide your configuration, and run it. That's it. It is something like test runner for your maybe Maven JUnit run, something like JUnit runner, Gradle test runner, or some test suite in Go or Node.js related technologies. If I provide you a couple of examples about these linters, for example, AirCheck in Golang, if you use a function and let's say that it returns an error after this function execution, if you do not handle this error, you will see it will generate a warning for you if you use AirCheck linter. That code, most probably you see this in your IDE. So if there is an unreachable code, you will get set of warnings produced by this dead code linter check. Struct check, again, there are different kind of checks on these structs. You know, structs are very important term in Go. And let's say that there is a struct, you export 5 fields out of this struct and you never use them. So you will see some kind of warnings. Okay, you have struct fields, they are capitalized, they are exposed to outside, but you never use them. Maybe you can make it private, right? GoVet, it is some kind of basic static code analysis for your Go projects. You can use this tool independently, and also you can use it within the Golang CI lint runner. VARCheck, as you can understand, if you define a variable and never use it, you will see a couple of warnings on your terminal. Usage is very easy. You can just download it, install this Golang CI lint in your workstation machine, whatever, terminal, computer, VM, whatever it is, and you can run it by Golang CI lint run. That's it. It will first have a look at if there is a configuration. If there is a configuration, it will how can I say that, the configure its internal configuration based on your file. If there is no file, it will use the default values. That's it. And this is a simple output of Golang CI lint run. I said that -- enable all. That means it will use all the linters exist in this how can I say that, set. And you see on not only the errors warnings, but there is a good property here. I said enable all, but you see interfacer, scope lint, melint, golint. Actually, they are deprecated, and you see it says the repository of the linter has been archived by the owner. This is very good information, I think. So you depend on a project, but actually it is archived. So it can be dangerous, right? I mean, there is no maintenance of that. You are saying that, okay, I am using scope lint and I am safe. No, you are not safe. You see it is being archived, and somehow you need to change this library and depend on another one. Maybe you can voluntarily just hand over this project and continue to maintain it, right? And one example here about linter check, you see by default in linter, it comes from one of the linter, funlen, function len. It is one of the anti-patterns in all of the languages. In Go, it is defined something like 40. If you have a function, it should be contains at most 40 lines. If you have 41, as in my case, you see I got this error. If you have more than 40 lines, then it seems that you need to extract this logic to some other set of sub-functions to do that. This is in my terminal, but of course it should be automated in different way. We will see it. Okay, the second part, vulnerability check. Especially you see nowadays last 1 week, you see Log4j everywhere, right? And these vulnerability checks are also important for your code base, because by using linters, you can have very, very basic set of security checks, but you cannot trust on them at all. In order to do this in a, let's say that apply the best practice, you need to have something dedicated to this domain. And I can suggest you a tool which is called CodeQL. And it is really good option for automation environment. If you do this manually, you will see it will have CodeQL database create. Here, what you say, go to the root of your project, create a database, provide your folder, of course, and specify the language. If you specify language, this analysis tool will do the analysis or create a database based on your language specified. That's it. And after create your database, you can analyze it. When you analyzing means, okay, get database analyzed, maybe you can generate some kind of report out of that. And of course, the best practice for this to use it GitHub Actions. You can do that manually. Of course, before the GitHub, this was done manually, but now you have chance to execute this within the GitHub Actions. The third step is the code coverage. In code coverage, running tests in Go is very simple. There is a naming conventions in Go. So if you create a test file and name your function starting with test, you will see they will be all detected as a test suites by using Go test command. If you provide the -cover option, you will see it will also calculate the coverage. When you provide cover profile output file, the coverage information will be put inside this file. And you see the output in the terminal. It says in Fibonacci, Fibonacci folder, we have 100% coverage, but on the other files, there are no tests at all. So Hüseyin, where can we use this output file, coverage out? So why we are generating this? We are generating because there are some set of tools that gets this coverage file and generates a report. You know, if there are Java developers here, you remember Jacopo exec files, right? Same strategy, very same. And I am using Code Climate for my open source project. And once you use it, you will see when you create your PR, there will be this code coverage step in my GitHub Actions. And by doing this, this output file is passed to the Code Climate execution, and they know how to build a UI based on this output coverage file. So you see there are 62 is not covered by my tests, but the other files are already covered with my test. That's it. So until this point, the main reason was to keep quality for my project code base. This is very important because it is very important because when you increase your team member size in this project, let's say the contributors, it will be a bit hard to maintain at all if you do not keep this quality as well. And of course, let's say that you are a contributor, you check the open source project, oh, this is a nasty code base, so I cannot involve in this project. So this is very bad for your reputation, right? So that's why you need to use this kind of quality gate checks. So about distribution, let's say that you have the cleanest code base in the world. If you do not provide a proper distribution channel, then you will see it will not good, because I am a Mac user, they are Windows user, they are using some kind of, they want to build this project from source code. Maybe they need Docker images, etc. So you need to somehow provide this kind of binaries so that it will be very easy for other developers to download and use it in a plug and play notation. First of all, Golang has a very good advantage on this building binaries, right? Right after you build binary, you can continue with the Docker image step. And then, of course, maybe for the quick insight, you can introduce these badges in your open source project. First of all, let's focus on the executable binary section. For executable binaries, what we do, Go is a very good language to compile some source code into an executable binary. So it is supported by default. First of all, you need to understand your environment. Go to this list. When you do this command, you will see the table of supported operating system and architecture pair. Here, for example, Darwin is my operating system. AMD 64 is my architecture, right? The CPU architecture. And based on this information, before you say go build, you can define your environment variables. For example, go operating system is Darwin, go architecture is AMD 64. So based on this information, this go build command will produce a binary for you that is supported by, that is suitable for Mac and AMD 64 CPU architecture. That's it. In GitHub Actions, there are a good feature which is matrix build, so you can provide as much as value here, and same build operation will be executed for this pair. So you can generate this build by using different set of parameters. I mean, operating system and the CPU architecture. Okay, when you generate your binary, and it will be very easy for you to generate Docker images. So in Docker generation phase, you can create a Docker file, and then you can use multi-stage build. I am saying multi-stage build because since I have an executable, I can provide this executable into any kind of Docker image as an entry point, right? So let's say that you have a Linux machine, you are about to start it. The only thing it needs just an entry point process. You remember this grub2 processes for your Linux distributions. And here in the first stage, I am saying that I am using Golang Alpine distribution for my Docker image. I create a folder which is called USR SRC app, and I copy all the source code to this folder. I download the dependencies by using gomod download, and then I build my executable, which is called hello in this case, and my operating system is Linux in this case. So I generated my binary in first phase, and now first stage, and now it is time to switch to second stage. In second stage, I am using a totally different Docker image, which is from scratch. Scratch is something like zero size Docker image, and there is nothing inside it. And I use zero size Docker image, and I copy my already generated binary from the first stage, which is builder. You can refer the first line. The alias is builder for the Golang image. And I copy this one from first folder to second folder, which is on the second stage. I provide this hello binary as an entry point to Scratch image, Docker image, and I expose 8080 to outside because most probably I serve my application through the 8080 port. That's it. So instead of having your Golang dependency, even in the runtime, because you don't need to have Golang dependency in your runtime, right? Because Golang is just can be a binary, and you can just execute a binary. You don't need to include Golang in the entire Docker image. In the second stage, we have only Scratch and the binary. Most probably you will have something like 1 megabyte, not 1 megabyte, but 2 megabyte image, but based on your dependency. If you have AWS SDK, kubectl, Kubernetes Go SDK dependency, this kind of libraries, you will see it will be increased a bit. But at the end, you can have something like 2 megabyte, 3 megabyte, and 4 megabyte images at the end. You see how portable it is. So especially within this kind of distributed environments, you have microservices. Each service has, let's say, that 5 replicas. So 6 megabyte Docker image, and it will be scaled automatically, very easy. Project badges. Project badges are very important because it really provides a quick insight about your project. When you open your README, you will see, okay, this is a Go project. Okay, when I click Go reference, I can see the Go doc. I can see the report for this project, maintainability score, test coverage. Even I can see the Docker image version. When I click on it, you will see it will redirect you to the Docker Hub, on my case, to see the Docker image for this project. And I mostly use Shield.io. Shield.io is something like project badge as a service. You can go there, search for any badge, for example, Docker image, test coverage, code climate, I mean, Stack Overflow. There are lots of badges there. You can provide your parameter. It can be user ID, GitHub repo name, Stack Overflow user ID, something like this. It can generate a badge for you, provide a full URL. You can just import this URL into your README file within a markdown notation. Also, you have another option, which is if you are using GitHub Actions, you can generate these badges within your GitHub Action job execution. So you have two options, maybe Shield.io, and you can use GitHub Action for this. So we are talking about the artifact generation. We are talking about artifact generation, but what about making it more easy? So in order to distribute your this artifact, you can use Go Releaser. Go Releaser is a very good tool to especially ship your product into any kind of destination. It can be Docker image, Brew, something like that. Even you can announce your releases within Discord, Slack, and Twitter. So Go Releaser has support cross-compile projects. So you can do a cross-compile because it is supported by Go. And you can release this one to GitHub, GitLab, and GTA if you want. Releasing means when you release something by Go Releaser, you will see it will create a release on your GitHub project. You know, when you go to the tags, you will see the separate tab, which is called release. When you click on that release, you will see some kind of changelog. You will see some kind of attached assets. It can be source code. It can be binary, Docker image link, etc. You can generate Docker images on the fly. So you can ship your Docker image in any kind of destination. And you can come up with a manifest. So let's say that you build a Docker image. You can tag it as latest and maybe tag it like 1.2.3. So it is a well-known best practice. Whenever you generate a Docker image, you can always tag it with the current version. Plus, you can tag it as latest. So you always update latest tag in the Docker Hub, and always you can tag the current version. That's it. You can deploy, you can ship this artifact to Brew, and also for the Mac users, they can download this dependency from the Brew, and you can announce this release to Slack, Discord, and Twitter automatically. So it is an end-to-end solution for your, how can I say that, product feature or tag or release operation. If you are using GitHub, I really suggest you to use GitHub Actions because everything is there. You don't need to do anything manual. For example, in the past, I was using some kind of Travis CI, Circle CI, this kind of tools for my build operations and do integration tests. But nowadays, I don't need them because everything is there in GitHub Action. Whatever I need, I search on the marketplace and I see everything. So, for example, for Golang CI lint, there is a GitHub Action for this. Just include it, provide parameters, and that's it. It really simplifies your flows, and CodeQL, code climate, linter, artifact generation, they are all available in GitHub Action. You can see the examples for that. Dependency maintenance. So you can think that it can be related to security, but also it can be related to linters because there is a new version. Maybe there is a performance improvements. There can be some kind of security improvements. You don't know that, right? But I am using Dependabot for this. Most probably you have heard this. There is a seamless integration with GitHub inside it. So in this part, Dependabot integration, you can use Dependabot YAML configuration, and that's it. So we will see an example, by the way, but when you integrate Dependabot, it will start to maintain your dependencies. So I am using, for example, Kubernetes Go module, and it warns me about, okay, you are using 0.22.3, but you can upgrade it to 0.23.1. And you can click on commit to see what is the change logs. And then, yeah, if you want, you can merge it. So dependabot is responsible for checking the dependency continuously, and then it just prepares a PR for you. The only thing you need to do is just check and merge the PR. That's it. Of course, it cannot be so that easy. For example, you can, so even you don't have a compile time problems, or your test coverages are okay, there is no security related problems, but you need to be on the safe side by doing end-to-end test. So let's say that I upgraded my Spring Boot version because dependabot just suggested me to do that. But when I run this application, I see, oh, there is a problem. Application is not running. It is running, started, but the functionality is broken. Why? Because from Spring Boot 2.2 to 2.3, when I upgraded, they changed the default content encoding. I mean, the content type. So it really break everything. So you need to somehow do end-to-end test. That's why these GitHub PR checks are really important for this kind of operations. But most probably, if you have, sorry, what is this? We can say that there is a minor change. There is no major change, right? The first digit is not changed. I can say that there is no major change, and I can freely upgrade this. But this semantic versioning is not something applied very well for all the projects. Even they introduce a major change, they can, when I have a look at the version, I see that there is no major change. But I don't know how maintainer works this with semantic versioning. Maybe they introduce major change, but incremented their minor version part. So to be on the safe side, just use the end-to-end test. So for the theoretical information, that was all. And I will show you a couple of examples for all of the theoretical topics. If you have any kind of questions, you can ask them, and in an async way, yeah, I can. We can answer the questions. Okay, so let me switch to the example. So I just wanted to start with Golang CI lint part. So I assume you see my screen well. Okay, here, first of all, when I open this project, we can analyze a couple of more projects, of course, but to be on the safe side, I just wanted to show them my examples. So when I open this project, you see there are some kind of badges, right? When you click on this, you can see the Docker image, but this is not actually a link. Okay, and this is code climate. When you click on the, for example, code climate, you can see the actual code. You can see the code coverage. For example, here it lists all the files. And when this column is for coverage, test coverage. And when I click on this line, where are you? Source and coverage. So I can see which lines are covered and which lines are not. So this is an example of how we are using these badges. When you click on Go reference, you will see it will go to the Go doc. So go here and see the actual documentation without cloning the project. Or if you are using a tool, something like Dash, which is a very good tool for documentation, you can just import there and see everything inside it. Okay, so let's have a look at this part. Whatever you have for GitHub action, you will see they are called workflows, right? GitHub workflows. And Dependabot has a special integration. So normally my integrations are here under the workflow. This is a special folder, by the way, known by GitHub itself. But Dependabot has something different, special integration. So that's why we have Dependabot in the root. Here, when you have a look at this part, I have only two configuration. First one is go mode. That means, okay, Dependabot, could you please analyze my dependencies? Just check them. I am using go mode. This is the go mode notation. And my directory is the root folder. And do this daily, please. So Dependabot checks my dependencies daily, and it creates PRs once needed, right? And also, my source code is okay, but do we really trust this GitHub folder? So what about this? Can you see my screen right now? Well, okay. So I am saying that, okay, dependabot, could you please track my dependency? I am using Go mode. But what about this GitHub action? I need to track also GitHub action, because GitHub action means you can use some kind of built-in features, but at the same time, you are using some kind of open source GitHub actions, the community maintained GitHub actions. So also I am saying that just track the dependencies for GitHub actions also. My root folder is this one, do that with daily. So if you are using Golang CI lint runner GitHub action, and this dependabot will also check the dependency for that GitHub action. GitHub action means it can be written in TypeScript, another language, or whatever it is, but it will track it for you. Very good methodology. And when I check workflows, you see I have continuous integration. It contains this linter stuff, code coverage. I have Docker image generation, and also I have vulnerability scanning. When I check continuous integration, here it is triggered by when I merge something into main branch, plus whenever you create a pull request against main branch, these jobs will be executed in order. So first of all, we check out the project. I say that, okay, I am using 118 for my Go projects. And then I am saying that, could you please execute Golang CI lint runner on this part? And timeout is 15 minutes. That means it may take some time to time. So I am saying that in 15 minutes, if it is not finished, just fail the job. And after that, you see it also executes code coverage, and there is a code coverage out file. And this test coverage step knows how to handle this coverage, because I am using code climate. And this is my reporter ID. This is not a confidential information, by the way. Since it is an open source project, you can also go to that code climate in order to see my results. I mean, here, this coverage file test coverage produces something. Code climate uses this file to generate the report. That's it. So for this file, yeah, I will show a couple of examples there. There is a manual Docker image generation here, but I will use the better solution on another project. But here, what I do is whenever you tag this project, it gets the release version from your Git information. I log into Docker Hub, this Docker username and token. Of course, never provide the credential confidential data in your GitHub action file. Just create a secret in GitHub and fetch it from the secrets notation here. Secrets, Docker Hub username and token. And after that, I build and push it to the Docker Hub in a way that Hüseyin Babal demory and version. This is the manual version. And finally, the vulnerability scanning. As I already said, whenever you create a pull request or whenever you merge it to main branch, this vulnerability scanning will be executed. So I use 117, and I am using CodeQL GitHub action. So if you are using GitHub action, everything becomes simpler. I am saying that just use language Go and CodeQL analysis. It just creates the database and analyze the database. That's it. Let me show you a couple of action job execution result. So here, this is one of the execution here. Build, test, and coverage. When I click, when you have a look at it, you will see the stages: setup, checkout, use. For example, there is a linter here. The linter job is executed, and there is no, let's say that, findings. There is no findings. And we do test coverage here, test coverage information, as you can see here. And there is some kind of coverage here, and test report uploaded to code climate successfully. What else? In GitHub Actions, we can also see vulnerability scanning. in vulnerability scanning, CodeQL. And it initializes CodeQL. As you can see here, it creates skeleton CodeQL database, and it analyzes it and extracting the information from this. If there is a failure, it will report, it will fail your job. So that is the main idea. And when I check pull request, you will see a couple of lots of, how can I say that, dependable stuff. For example, there is API, client Go, API machinery, etc. So let me go to the client Go here. This is generated by Dependabot. You see, you can see the commits here, what is inside it. So Dependabot is very good on this. It generates lots of useful change logs for you. So I can say that this is okay for me. Let's merge this one. Delete branch. There is some certain comments here. Okay, Dependabot create. Okay, and when I go to pull requests, right, there are a couple of pull requests here. I just wanted to see if they are still valid or not. In order to refresh them, when I say Dependabot create, it will say, okay, I will handle it. You see, I added this comment, and Dependabot says me, okay, I will handle it. So most probably it will rebasing this part. Okay, most probably it will reduce the PRs. You see, it was 5 and it is reduced to 4. Why? Because I already merged something and it deprecated one of the previous PRs. So it's really cool. You can have a look and see what is there, what are their options. And finally, I just wanted to show you about Go Releaser. This is very cool project. And here, there is almost zero configuration. In release YAML, I am using this. This is a hypervisor emulator, by the way. So because since we are generating some artifacts based on different architecture operating system, this Kemal project is something for that, hypervisor. So it simulates these architectures and underlying operating systems. I log into Docker here, and Docker login plugin, but actually I am logging to GitHub's own container registry. This is GitHub container registry. I am the owner, so you can get these predefined variables, set up Go, and run Go releaser action again. So it generates all the packages, it releases it to destination with this GitHub action, a GitHub container registry on this case, and that's it. So let me check if there's a configuration here. Yeah, Go releaser YAML, this one. And here, I basically define my parameter. This I have a separate session for this. Again, you can go to my profile and check the related session. And this is for specifying how to generate your artifacts, including the Docker executable, and how to generate your Docker manifest. So on my case, I am building, let's see the outputs one of these, and you will better understand it. One of the output of this one. Yeah, Go releaser. You see, it tags this project as 008 because this is my final tag, git tag, and also it pushes this one as a latest. So whenever you introduce new tag, it will generate a Docker image based on that tag, tag it, push it to GitHub container registry, and also it will tag as a latest to keep latest tag as up to date. And when we have a look at this releases page here, releases, you see it is automatically created by Go releaser. When you have a look at that, there is a commit history change log. You can see the Docker image, how to pull Docker image here. And you can see all the artifacts are attached here. TARs files, some AMD64, zip, TARGZ. So you don't need to think about this process. So if you have this kind of Go projects, just use Go releaser. This is specifically for Go projects. So that's all, by the way, all theoretical. And I hope this demo also was very useful for you. And I think we are out of time. So thank you all for listening, and I can happily answer question if I can. I don't know, Safa.
Yeah, okay, that was definitely a great presentation, Hussein. So thank you for that. I'm just checking the comments, but I can't see any questions actually. But if anyone has any question, how they should reach out to you?
Yeah, you can just ping me in Twitter, or you can go to my GitHub profile and check whatever link you prefer.
Okay. Thank you, Hussein, for your time and your presentation. So see you next time again, hopefully.
Okay, thank you all. Thank you, GopherCon Turkey. Bye.
Okay, bye. Take care. Okay, so now we have 15 minutes for the next presentation, and we will be here at 3 o'clock. So see you in 50 minutes. Okay, for now on, we saw definitely awesome presentations, and let's continue with other awesome one. So our next speaker is Burak Tahtacı. Burak is working as a security RD engineer at Trendyol, and he will be talking about extending kernel with Go and eBPF. So let's welcome him. Hey, Burak, how are you?
Very well, and you?
And we are definitely great, and good to see you in here. So I don't want to take your time, so you can take it away. Good luck.
Okay, thanks. Thanks, Sefa. Hello, everyone. Welcome to my presentation. And today we are going to talk about the extending Linux kernel with Go and eBPF, which is an interesting technology. And this will be an overview to eBPF from Go perspective. Let me introduce myself. My name is Burak Tahtacı, and I'm working for Trendyol Tech as a software engineer. In most of my time, I'm doing security research and developing security software for 5 years. Okay, here is the agenda today. First of all, we will talk about the Linux kernel and its behavior, and then we will talk about basically how the eBPF works and what are the main concepts of them. Also, we will cover some of Go libraries and SDKs for loading and running eBPF programs in kernel. And finally, we will do hands-on coding and seeing in real-life cases with Go and eBPF. Okay, let's get started. I'd like to begin by the kernel itself. As you know that the kernel is the most privileged part of an operating system. It manages all the system resources, and the kernel is the center of the management for an operating system. So if you can introspect the kernel, we can get very detailed insights about our system. For this reason, kernel is the best place to implement observability, security, and networking applications as well. Because kernel has capabilities that can oversee all the events that are communicating with hardware and the other system resources. So how we can extend our kernel through observability, networking, and security verticals? How to add new features or changing existing ones with relating with them? And what are the options? First of all, the kernel modules. Kernel modules, Linux supports the kernel modules, which are dynamically loadable programs into the kernel at runtime. It looks as a handy solution to add new features because you don't need to recompile the kernel or reboot them. However, there are some drawbacks for the kernel modules. Kernel modules does not support any mechanism to check the module is safe or not. So if there is a bug inside your kernel module, it may crash your kernel. So there is not any verification layer before the execution. In addition, the kernel modules depends on your kernel version. When your kernel version is changed, you might need to change your kernel modules code. The second option is changing the kernel source code and adding your awesome features inside the upstream Linux kernel code base. However, it might be pretty hard to get accepted for each change on your Linux kernel from the community. So the last one is really hard. So writing your own kernel may cost very, very huge. For example, the cost of writing Linux kernel from scratch may cost $1.5 billion. Yeah, there might be a good solution for this. So before we get started, we need to understand how the kernel works exactly. Linux kernel is event-driven. For example, all the components in the kernel are events. For example, system calls are events, hardware interrupts are events, or incoming or outgoing network packets are each of them is events. So kernel is also intermediary technology between the user-level processes and the hardware. So it abstracts the hardware from user and exposes drivers and programming interfaces. And each operation kernel can be treated as an event or interrupt. So the question is here, is there any way to hook these kernel functions for tracing or manipulating those events? So the answer is eBPF, which stands for Extended Berkeley Packet Filter. The classic BPF developed in 1992, and it was used to process network packets in an in-kernel virtual machine. BPF virtual machine was an execution environment for our BPF programs for packet filtering or packet manipulation purposes. It makes it easier to develop high-performance packet filtering applications in kernel. So BPF is very powerful. However, it's limited to packet processing domain. So the eBPF is the extended version of it. eBPF can hook many different points in addition to its networking capabilities. So it boosts the capability of visibility inside the Linux kernel. So we can basically define eBPF is a virtual machine that is running inside our kernel, and we can run our arbitrary user level codes in it. So let's look at the eBPF's technical perspective. Okay, there is a virtual machine inside the kernel. And this is a sandbox environment to execute our BPF programs. And we have a user level driver application, which is developed in high-level language. And the driver program loads the kernel programs into the virtual machine. So many high-level languages, such as Go, C++, Rust, or LLVM, supports the SDKs and provides SDKs to develop user-level applications with eBPF. And the SDKs can provide a way to do load kernel programs into the kernel VM. So actually, the eBPF kernel programs written in a restricted C language, which is different from the ANSI. Some of the features in C are excluded from this language in order to ensure that the kernel programs are safe to run in the kernel and it will not crash our kernel. For example, this restricted C language has not any loops, no global variables, or no floating point operations, and so on. This language is not Turing complete. Okay, as you can see here, there is an example of eBPF kernel program, something like looks like this. This function attached to the execve system call and gets the commands which is executed, as you can see here, event.com. So this program basically listens for each execve system calls is triggered and extracts data from this event. Okay. To run this kernel code inside the kernel VM, we need to compile this them into the eBPF bytecode. So the Clang compiler utilized here, this translates this compiles the C code into the eBPF bytecode. So the compiled BPF codes look like this. This is the instruction set of eBPF virtual machine. This bytecode is now ready to install, to load inside the VM. And this eBPF VM only accepts something like that, this bytecode. And the SDKs can load these bytecodes into the VM directly. So just before loading to the VM, we must ensure that our code, our bytecode, needs to be safe to run in the kernel, because it will not crash the entire system, because if the kernel crashes, all the system crashes. And there's an architecture here that is called verifier. It basically checks our bytecode is safe to run in the kernel. So during execution, the verified bytecodes are translated into native CPU instructions, as we know, the push, pop, or something else. And the virtual machine actually running on the hardware. So just-in-time compiler is the essential part of the eBPF's performance. So it translates each bytecode instruction into the CPU instructions on the fly. So it makes eBPF programs run fast the natively compiled programs. So after the compilation stuff, our eBPF program is ready to hook the event. Okay, BPF was already developed to hook networking-related events, as we know. But eBPF can hook many points inside the kernel. For example, kprobes is one of them. The kprobes are the entry points of the kernel level functions, which can monitor the beginning of the events. So, and K-ret probes is the return points of the kernel level functions. eBPF is also can hook many other things like system calls or even user level functions. To keep track of the user level processes with eBPF is possible. So these features makes eBPF is a high performance introspection tool for the Linux kernel. So we can get very detailed insights and metrics about the system through these system call hooks. Okay, in order to develop the eBPF kernel programs, there are some helper functions inside the kernel, which is called the kernel helper functions, and it makes the development of eBPF kernel programs easier. So it contains some of the useful functions, for example, the random number generation or getting system time or printing messages or accessing BPF maps and so on. All these stuff are really useful while we are developing programs in kernel. Okay, another essential part in the eBPF world is maps, eBPF maps. Basically, the eBPF bytecodes are just executables. There is not any data inside of it. But sometimes your eBPF programs need to store its states, its metrics, or any kind of data. So maps are the solution here. Maps are the data storage and transmission system for eBPF. This is a two-way data communication channel between our user-level driver application and the kernel eBPF program. So we can enable to send data from kernel to user or user to kernel level. Okay, the map supports very well-known data structures such as hash tables, LRU caches, or longest prefix matches, or stack traces, and so on. They are very useful to communicate each processes from kernel or user space. As you can see that the eBPF provides high-performance kernel tracing and observability options. So let's talk about some real-life use cases of eBPF, how we can use the eBPF actually in real world. Simply, main three categories could be covered with eBPF. The first one is observability. We can cover observability via event hooks, so eBPF can hook many points inside the kernel, and we can get inside and collect metrics or access the state of each function call. And every point inside the kernel, eBPF can do the observability very well. And another case is about networking. So eBPF has strong abilities to work with network packets and manipulate them. Therefore, the high-performance traffic controlling and layer 4 load balancing applications could be developed via eBPF. And also, the eBPF can be utilized in some of security applications, such as intrusion detection systems, firewalls, or runtime security applications. So, all right, here's the thing, how we can write eBPF programs by using Go. And there are lots of ways to do it, but today I will cover two of them, which I've used before. The first of all, the eBPF Go library, which is developed by Cilium and Cloudflare. This is a pure Go library that mimics the libbpf capabilities. libbpf is the original BPF implementation that is in the upstream Linux kernel. So this library is very well documented and well tested. In addition, this library is the core technology behind the Cilium CNI. So it has a broad production use in networking and packet processing domains. The other project is GoBPF, which is developed as a part of IOVisor's BPF compiler collection project, which is called BCC. BCC provides lots of useful tools to load and run eBPF programs. It abstracts the logic behind the compilation and verification from the user. So it's easy to develop eBPF programs with BCC. So this library focuses on the tracing. So, but the BCC is originally developed for Python, and GoBPF is the Go wrapper for BCC. Okay. I wanted to mention about an interesting technology which is called XDP. It stands for the Express Data Path, which is a part of the upstream Linux kernel, and it enables users to load packet processing programs into the kernel as early as possible layers, such as drivers or network interface cards. So packets can be processed before the kernel's TCP/IP stack does. So the eBPF programs can be loaded into many points before the actual Linux packet processing subsystem. So, for example, our XDP programs can be loaded onto the network hardware, which is called offloaded XDP, because all the packet filtering logic is offloaded onto the NIC besides the CPU. If our network card does not support the XDP can also inject our codes onto the network driver or early steps at the Linux networking stack. This makes the packet processing applications as early as possible, so the packet manipulation is extremely high performance when compared to the other traditional approaches. On the other hand, XDP sometimes referred as the kernel bypass technique because we can run code directly inside our hardware via bypassing our kernel. So it's similar to direct memory access in file operations. Okay, now it's the demo time. We will do a simple demo. We will look at some codes in action, which is a simple network intrusion prevention system. Here is the simple pseudocode or explanation how our demo works. We will first capture the network packets before the kernel does via XDP, and we will check the flags of the TCP packets that is incoming to our host. And if there is an mmap finscan here, we will drop these packets to protect our host from the port scanners. All right, and then when we capture the port scan here, we will notify our user level driver program which attacker's IP, and we will pass through the eBPF maps onto the user level. If there's not fancy, we will pass the packet to the user level. All right, let's talk about some code. Here, there are simply two hosts here. This is the first one. This is my laptop here. We will behave as an attacker to our VM, and we will develop our code onto this VM. This is a Ubuntu server. And our XDP program consists of mainly two parts. The first one is the kernel program, which is xdp.bpf.c, which is a restricted C program, as we mentioned before. So let's deep dive into the code. We have a function here that is called hello XDP, and it takes a parameter that is XDP context. And this context have the actual network data in it. So the parameter of the data variable contains our each network packet. So we need to parse them into the TCP/IP stacking sequence. For example, firstly, we need to parse the Ethernet header here, and then we will parse the IP header and get some useful stuff in IP header, and we will check the protocol, which is that. For example, IP proto TCP is here. If there's a TCP packet, the condition will work. And we will parse the TCP header here. And here is the logic, the prevention logic here. So we get the source port and destination port from the TCP header, and we will check the header. If there is a fin scan, this is a technique that can be done via attackers on our hosts, which is only fin flag is set as 1, and the other flags remain 0. So this function basically does that and returns as a 1 if this is true, and 0 it is false. So if this is an nmap scan, so we will drop the packet via XDP drop directive. Or everything is fine, the packet will be passed through the kernel via XDP pass directive. Okay, if the value is triggered, so if the function is triggered, we will add the source IP. This is the attacker, and we will set the attacker to our BPF map, which is can be defined here. It's the hash map that names the attackers. The key value is integer, and the value is integer. So we will store the IPs as an integer here, and we will count how many packets drop from this IP. So we will increase the dropped packet count from our BPF map. And all the stuff is okay for our kernel program. And let's go to our Go site, and let's see our Go code. Okay, we have some useful functions here. So, for example, usage or integer to IP translation function, as we discussed before, and there is some error handling function, and the logic starts from here. First of all, we read the actual C code. This is the kernel code, which is running in the kernel in the XDP virtual machine. We will read this code via OS read file. And then we will use a BPF module, which is our IOVisors Go BPF. We will use it, this library today. Okay, we will create a new module via new module function from this source code. And then the module object is created. So we have a function inside our kernel program, which is called hello XDP. We will load the function called hello XDP as a BPF prototype XDP. And then we get the function here. So we will attach the function for a network device to trigger each incoming or outgoing packet is triggered. So we will set the device from the OS arguments. And the attach XDP function attaches this function to the given network device. And this function triggered when the packet goes through this interface. Okay, all the stuff is here. And we have a BPF map, as we discussed before here. This is called attackers, which is a hash map. The key is integer and value is integer. So we need to implement here in Go side. So we have to create a new object that is called attackers with bpf.newTable function. We will pass the attackers the same name from the C code. And our BPF map can be accessed via this variable. And when we start the program, it waits the Control-C as program command. If the program killed, the contents of our BPF map will be printed onto the screen. Let's look at how it's work in real life. Let's start our nmap scan from our host to our victim VM. We will start a nmap scan. And you can see that there are two ports are open. The 2020 and 80 is open. And nmap can determine which is open. And we will start our Go program here, which protects from the nmap scans, nmap fin scans especially. We can run our main Go program with our interface name, as we said before here. So first we get the interface name from ifconfig. This is emp03s3. So sudo go run main.go and the interface name. Let's start our program. The eBPF programs needs to sudo privileges before start. So our program is running and it started to protect from the nmap fin scans us. Let's start the nmap scan again. So there is no output here because all the packets that is sent from Nmap is dropped by our eBPF program. When we kill our protector program or eBPF program, you can see that the more than 1,000 packets is dropped from this host. As you can see here, we will implement a security application, which is a very tiny, but it may be useful. So all the things that I've said is today okay. And if you have any question, we can I can answer your questions now.
Yeah, I think there is no question right now, but are you going to continue your presentation, Burak?
Yeah, that's all.
Okay.
And I will be at the Discord channel, and I can answer any questions here.
Okay, I'm just looking at the comments right now, but I don't see any questions. But like Burak said, if you have any questions, you can reach out to Burak at Discord channel. And yeah, that was definitely a great presentation, Burak. So and
Thanks, everyone.
Yep, and thank you for your time and presentation. So see you next time again, hopefully.
Okay, thanks. See you, Sabah.
Bye. Take care. So, okay, so our next presentation will be at 4 o'clock. So we have like 30 minutes. So we are giving like 30 minutes break. So see you in 4 o'clock. Okay, hello everyone. Welcome back again. We hope that everyone is enjoying same as us from the event. So we have three presentations still, and so let's continue with our next speaker. So our next speaker is Engin Diri. Engin is working as a developer advocate and Schwarz IT, and he will be talking about to make or not to make alternative ways to build your Go app. So let's welcome him.
Hello.
Hello, Engin.
Hello.
How
Can
are
you hear me? Fine, and you?
Yep. Yeah.
Okay.
Yeah, I'm pretty fine. So it's good to see him. So we are so excited for your talk today. I don't want to take your time actually. So if you can share your screen, I can leave the stage to you.
Okay, that's perfect. So I will share my PowerPoint presentation, and I hope you can see this because I will not see the screen anymore. So please let me know if there's some issues. So then let me see that I will share my whole screen and also start the presentation.
Okay. Okay.
Everything's
good luck,
working? Okay.
Yep.
Thanks a lot.
That's totally working.
So, okay, then yeah, welcome to this session. Thanks of all again for Go Turkey for hosting this event and make it possible that we can present such interesting topics. And some of the topics I already visited before were really, really interesting. So let me start with my one. So I want to show you, I want to answer the question actually to say, okay, should I use make or should I not make? What are the alternatives we have to build our Go applications, for example? So that's an interesting question. I will lead to this, why I came up with this question to say, is there something else I can use, especially with me? And I will go into this. So just quickly introduce myself. So my name is Engin Diri. I'm working in the Schwarz group. These are the persons probably some of you may know or may not know are the persons behind Lidl and Kaufland. So it's a discounter and a retailer, and Kaufland is the bigger discounter. I'm working in the IT department of the Schwarz group and delivering different kind of projects to our customer. I'm mainly in the transformation, cloud transformation enablement around and being occupied and helping different projects to do the cloud transformation. So that's very, very interesting. And of course, I'm also on Twitter. So if you really want to see some memes and sometimes technical stuff, feel free to follow me on Twitter or Instagram. So that's completely fine. Okay. The agenda for today. So I just want to go quickly through how to build a Go app. That's really interesting. Just a refresher. I know that most of you, because it's a Go conference, will probably know like this, but it's always good to see again where everything started and then go through the different topics to say, okay, what are the alternatives? So we know, for example, there is a possibility called Mage where we can use, for example, Mage. We have the opportunity with Task. So there's a tool called Task we can use. We have, as Hüseyin just before mentioned, we have also Go Release. So I would call the Swiss Army knife of for Go applications. And of course, we have this little thing called the Dogger multi-stage builds. And I want to show this also in an example. And after all, we have enough time for questions. And I'm really curious to see what's your feedback on this. Okay, so again, just a little bit background to start from where I come from, because I found this interesting. For me, for example, Go is not my first language. So I moved from classical language. So my background is more, I started my university and my study and my first work career working heavily with Java. So you can imagine the stuff with Java SE, moving up the whole stack, discovering Spring, and front-end wise, I was already on the JavaScript train, so using also there heavily the JavaScript frameworks which were available at this time, and the most famous one you already know with Angular, Vue at the moment. So my background to build the code I created for on the Java side is Maven, for example. Everybody knows. So I have an abstraction inside we use XML, for example. I know that I have a defined structure to create this stuff. I have my tags. I can put my build plugins in, and I know everything gets executed in this order. There is a fixed defined life cycle behind this. So this is one of my point I heavily used and get used to build my applications. And Gradle, of course. I mean, everybody knows. I mean, if you're still working with Android, for example, you probably also use Gradle to build your application or your mobile application or whatever you're going to build. So also there, we have, again, an abstraction layer between our actual project. We have a defined structure. We have a defined DSL language, for example, where we can follow the pattern. So this is also very interesting and very guided. And of course, with Node, everybody knows with the package JSON, we could put script tags inside, and then we can execute also the applications. But there's also a little plot twist inside. When I worked, I'm not sure anymore if you still use this nowadays, but when I worked, for example, with the front-end project, I also used Gulp. And this was very interesting because I could use, for example, JavaScript to build my JavaScript project. I found this very interesting. It's like the whole infrastructure code part, for example, like Pulumi is doing, to use a real language to define the deployment on a cloud provider or whatever. So that's really interesting. And of course, Grunt. So these are the technologies I always used to create my application. And where is it? Of course, I also used Make. I mean, there were some times where I had some really C programs where some Make files were already there, and I had to use Make. And this is also where I'm coming from to say, okay, Make was for me always something I could not really get my head around. I mean, it was very close to Bash, and if I need to write some Bash files, for me it's always like this. I write it, 5 minutes later I forgot about it, and I have to look it up again. I'm really, the only time I'm really heavily on Stack Overflow and in the internet looking up for resources was always when I have some kind of contact with Bash files, because I don't know why I'm not able to memorize this stuff. So this is really a thing, and that's the thing. I really feel uncomfortable. This is really one of the times I feel like I don't know what I'm doing, and I have to look it up. And when I come to my Bash scripts I wrote, I'm like, what the hell did I do there? And it feels like a Frankenstein application. You know, you copy paste the stuff together, you're happy, you pray, and it works, and you're like, okay, I'm done. I never want to see this stuff. So that's for me the question. And when I started with Go, it was at the beginning of this year. So as I said, I'm not a Go developer since years. So I started with version 1.16. I also encountered quickly that many projects, Hüseyin also explained this, if you're in the open source world and you want to contribute or you want to create your own open source project, you will encounter always this make files. So that's the thing. So there are, for me, it was like, oh, I need to get my head around the make stuff. But happily, there are alternatives. I mean, there are alternatives, and are they easier? That's another question. I mean, I cannot say, and we will see this also in the examples I prepared. It's not that you will get maybe an easier approach to the make files. So maybe you have to see what you're changing. You say, okay, am I going maybe for the readability? Am I going maybe for the native integration of the other solutions? So you have to see which solution fits better. But it was for me, when I tried the different alternatives and we used them in our company, for example, and in our projects, I always was, okay, I have to weight both stuff, and I have to say, okay, what I want to do, which one I can scale out. Maybe I'm not anymore in the project and there are people getting this project. What level are they? What expecting they? Maybe they are strong with make and they want to continue make. So it's really interesting question, but it's worth to, again, to see what alternatives we have and decide then on a case by case if you want to continue with one solution or you want to abandon the other one. So again, the question is, which solution, which automation tool solution I should use. And here again, that's maybe something, it comes up more and more, and you already maybe heard this also in your life. It really depends again. It really depends what's going on. But again, it's good to know the alternatives, and then you can decide if your use case, if your project, what maturity level has your project, to decide it's absolutely fine to use this piece of technology. And if you grow or you outgrow the current situation, you can still change the stuff. So that's very interesting also. Okay, so quickly, I don't want to bore you too much, a little bit about the basic stuff to say, okay, what's the way we actually build our Go application? And again, I would like to go only on the happy path, because as you know, when you write, for example, Go build and you make a -h, you will see plenty of flags you can set. So I'm sure that you can really go mental with all the possibilities. So here again, just a quick thing. So the main way, and this is, I mean, everybody who starts with Go from the hello world use case to whatever bigger application is always using the Go build command. And then you can start to refine the stuff to say, okay, what is all in the main package and how I want to rename the binary, what's coming out. Do I have some linker flags I want to set, and so on and so on. But starting point is the Go build. So nothing new on this side. And now we add now comes the next step. We know that with Go, we have a cross-compiling. So that's really nice. And Hüseyin just explained it also when he explained the GitHub Actions, for example, with the QEMU and enabling this stuff to be sure that you can build and run the application on the different runtimes. Here with Go, we can set different flags, the OS flag, the architecture flag, to say, okay, for which platform we want to build our code. So you see, it starts again. Now we are not anymore on the level to say, okay, Go build. We start now to add additional stuff. It's not something anymore where you say, okay, I write this in a README, copy paste this. I mean, we are not a machine. We don't want to copy paste the commands all the time. So that's something for sure. And then, as I said before, we start with all the parameters. I mean, LD, the linker flags are the flags, the most obvious one, and the one everybody is using, be it here in this use case, just to paste some variables from extern, maybe the version, the commit ID, or whatever you want to put into your project during compile time, you can set with these flags. So as you can see now, things start to grow, and this is not something anymore you put in a README and you copy paste, and you definitely don't want to do it by hand. So it's completely obvious that you want to use some kind of automatism, some kind of description to say, okay, these are the steps. This is a dependency tree. I want to do a Go mod tidy. I want to do a Go mod or a Go test. I want to call Golang CI for the linting stuff. So you already have some kind of dependency graph in your head, and on the different steps you want to perform for creating your release or for creating your binary, be it a test or a release binary. So that's completely fine. So then we come to the golden standard. I mean, then now we come to the situation with makefiles. I mean, that's really something. When I prepared again, I didn't want to talk about something where people say, hey, that's not true or something like this, but I checked the major external projects, for example, the Kubernetes project or the Prometheus and so on, the stuff we already use every day, and they have all fancy makefiles. So that's something we encounter already. So is this the gold standard? And I looked around, I was like, okay, what does the people say? Maybe it's just me. I mean, I can be stupid and so on. And okay, I don't understand it. Maybe I'm not this smart as I thought I am. So let me see what other people think about. So I typed in, I went to Twitter, for example. I was just, okay, let me see what people tweet about Makefile. And then boom, comes one tweet in your hand where a person, sorry for the swearing word, he's like, oh my God, this is something, he hates it. So that's very interesting. Or we have another one where it's more politely to say, okay, I'm not a real fan of bash and makefiles. Yeah, it's similar to me. That's the same thing. So we see the tendency, but not only on Twitter. I mean, we know on Twitter the people come and wants to complain or something like this. How is it, for example, on Hacker News or on Reddit, for example? And there are also plenty of threads where people just don't feel comfortable with Makefile. They understand the need and they see the benefits maybe, but they don't feel comfortable. And one big thing, for example, this is now just a random Google search where I said, okay, let me look for makefiles suck, for example. And there are also entry where people are really, really upset about the whole makefile experience. So that's a really good point to again, when we go back to our initial question, to say, to make or not to make, what are the alternatives? Maybe it's okay, again, to check the alternatives. So I want to quickly prime you on makefiles to say, okay, what is the deal about this? I mean, some really introduction. I mean, I cannot really go deep into the whole makefile stuff, but I think it makes sense to just quickly give you some feedback. So again, makefiles, as you see now from the feedback, from the tweets and the Google results, for example, it looks like they spark some kind of controversy. So it's really like either you hate it, or you love it, or you're in between, something like this. So yeah, I have to use it, but you know, I don't want to use it. So makefiles, I mean, some people would say they are just fancy bash scripts, and actually they are like this. I mean, they're coordinating like this. They have a unique take on the user experience, on the developer experience. So it's something you really have to get familiar and have to understand, because, okay, this is say like this, because makefiles are really, I would not say old, but they are really, and I say that here with battle-proof. I mean, they are not something like a thing from the last couple of years. I mean, makefiles are there since ages. I mean, in the old times in C and so on, people already wrote makefiles. So they are battle-proof. I mean, we cannot say that this is something, I don't want to deny the success of them and the way they handle the stuff. So they are battle-proof over time. But as you can see, over the time, we learned new ways of organizing our work, organizing our automation and all this kind of stuff, and increasing our usability and our developer experience. We see that they're coming two worlds together. And now that's the situation. So the unique take of the UX, and it's what makes everything more complicated. Okay, so just a quick overview over the makefiles. So this is really some stuff where you start, okay, I was also like this, okay, we have our target, we can use our prerequisites, and then we come up with the commands. And this is the shell commands. You write everything in the shell commands. You can define variables on the top of it. So yeah, everything that's still okay. But quickly we come into this situation. So this is actually a real one. I put also the link there. That's the one from Prometheus. So it's from their common makefile example. And as you can see, it really grows up quite quickly. And again, as I started before to say, I mean, yeah, I understand it. Maybe when I'm working in, maybe I need to deep dive into it because I'm doing some stuff. But the moment I left it, I changed my work and I need to come back maybe a couple of weeks, days later. I'm like, what is this? What did I wrote there? And what is again? And how do you do a loop again in shell? And how do I truncate the stuff? So that's the situation we have. Okay. So let us come to the first alternative. Again, we'll go later into the code, so you will see this little bit code. I thought about maybe to interrupt the slide with the code, but let us just go through the alternatives, and then when we see them again in code, I will remind you and say, okay, this is now the topic of Mage, for example. So we have one of the solutions is Mage, and Mage is a rake-like build tool completely using in Go. So this is really, really interesting. That's a really nice approach. So you can use it's written completely in Go. It has I put it here again. It has some helper libraries bundled in, so you can use some functionalities they provide to you, but then everything is in Go. And this is really, really interesting because I can use the full power of Go and the libraries, and whatever I want to use, I can create loops and everything. I can even test the stuff and run, for example, my linting also over it. So everything I'm used to during my daily work when I write the application goes now into the way I build the application itself. And this is really, really interesting. And when you look at it, and we see later the demonstration, you feel instantly familiar, and you're like, okay, that's completely fine. Even when you take it out after a certain time, because you are a Go developer, you're like, oh yeah, okay, that's it. That makes absolutely sense. So Mage is really an interesting stuff. Again, we will see, I mean, you will find also out, okay, this is again, everything which is written in a programming language. You have to keep in mind that you will start also to get some technical depths. So this is like infrastructure as code, where you write code. The moment you write this kind of codes, you have to keep in mind that you maybe get some technical depths in, or that you also write rubbish make files or Mage files. So that's something to keep in mind. But definitely very interesting. So we will see this in detail. The other one I call tasks. So the whole don't forget the milk is all about having a task list. So the next candidate is task. It's also written completely in Go itself. And the installation is also quite easy. So you can just install it via brew, for example. It's a single binary you can install. That's very, very interesting. And the plot twist in task is you can use YAML. I mean, I know that YAML is a thing everybody is discussing about. Is YAML good or is YAML bad? But here in this case, it's used a simple YAML file, but completely enriched again with the Go world. So you can use, for example, the Go templating inside of the YAML files, which is really, really nice. And again, you have something very familiar, because when you use, for example, Kubernetes or other technologies, I mean, there are plenty of existing technologies who use also YAML, for example. So in this case, it's actually something, okay, it's well structured. I can see this. I can run again some tools over it to confirm that everything is written. I have a JSON schema file, for example, so I get also there instant feedback if I'm miswrite something or have some issues with the child elements and so on. So this is really, really interesting also here. And task has also really powerful code generation parts. I mean, when you create, you can set timestamps for generating the files. He will check them, and he will not execute the task, for example, if there's already created one and your condition is still valid. He will not recreate the task. And this is also very interesting. And again, you can create whole dependency structures. You can here again say, I built my graph. These are the preconditions I want to do. Or you can call tasks inside tasks. You can create also a task file library where you say, okay, I have some generic task I always want to use also in other projects. So you can create also task file templates, for example, and include them into your actual project. So this is, again, very, very nice functionality. And as I said before, written in Go, using the Go templating, very interesting. So this is the task part. And now we come again. Hüseyin also mentioned this, and this is something you will 100% encounter when you work in Go, is Go Releaser. This is the absolute Swiss Army knife of build automation release tool, all in one, baked in. I mean, there's so much functionality. You could really literally create a dedicated session just for Go Releaser. But here, it makes absolutely sense to put this also here in place to say, okay, Go Releaser is the automation tool for Go projects. Go Releaser is completely built with CI in mind. So everything, I mean, they have a huge integration part for CIs. They support from Azure DevOps, from GitHub Actions and so on. So everything is really thought for using it in your pipelines. That's very, very interesting to have this already by design thought about when you create this stuff, that you say, okay, one of the primary goals where I'm going to use this is in my CI tools. And again, Hüseyin also mentioned this, you have plenty of customization options. I mean, you don't need to write any additional stuff. You can say, okay, I want to publish it to my own brew tab, for example. You can configure this. I want to send some Twitter messages when I release my application, for example. So again, there's also much to do. We will see later a little bit in detail how we, for example, then do the use case. So very interesting. And also worth mentioning is, of course, the Docker multi-stage builds. I mean, this is also very interesting. I found this appealing. I mean, there is some really interesting charm on it, and I will go into this. I mean, I like the way that, for example, I can create immutable builds through fixed versions. So I can run every step in my, I mean, I can put many steps into it, and I can run every step in a specific container, in a specific container version. So I can really pinpoint the specific version through the SHA, for example. I mean, I don't even need to write this this human readable version, like version 1.0.0 or whatever. I can write the SHA number behind this, and I'm sure whatever I'm doing, as long as the container is still available, either through Docker Hub or through my internal registry like Artifactory or whatever you are using, I will always get this version. And I'm sure when I build the version, when I execute my build, it's as close as the person who wrote the file thought about it. I mean, still you could have not a reproducible build because you somehow missed something. I mean, this is still the possibility. For example, in Node.js, you set some version conditions and he will get the latest version. So this is something not thought. But if you take care and your build is everything set up to create this reproducible builds, what a word, you can be sure that this is really an addition on top of it to have this immutable approach. And with the immutability comes also the reproducible. I always mention this. But here having also the transportability between the different stages. So I can say this multi-stage file runs also on my CI server, but I can use the same one on my local client too. So we have now a common contract, we have a common language created here, and we can be sure that when an error appears, for example, I can at least execute this, for example, in my local machine and see, okay, what is the issue there? So we have something, or our colleague starts in the company and he wants to continue to work on this. You can say, okay, you don't need to create maybe your local Go version. Maybe it's a different Go version. You have 1.17.1 and he has 1.16 or something like this. And then you get maybe some issues and you're like, okay, there is an issue. And you're like, which version do you have? Which version of a supporting tool do you have underneath? And here you can create, you can define everything in your multi-stage, and you can be sure, because of the fixed version and the containers you're using, it's always be the same one for every person. And here again, we have one situation here that it depends on the Docker CLI. Yeah, I know there are some projects outside who can use this, who tries to emulate as much as possible from the Docker DSL. I'm not 100% sure that every alternative is running multi-stage builds, for example, perfectly and understands all the stuff. I mean, it could be possible. Last time I checked this, there was the mentioning that some of the Docker DSL commands are not 100% working on this. For me, it doesn't matter because I'm using Docker Desktop, and in my company, they're using also Docker Desktop. So that's completely fine for us. This is a drawback. I'm completely d'accord to use this. Okay, so we set up the scene, and we talk now about different stuff. So let us see how this is going to look like in a demo. So nothing big. So there will be code. I hope that's okay for all of you. And we'll see this in the code. So, okay, again, let me open my IDE. So I'm using IntelliJ. So that's it's really not depending on this. And let us see how we created the demo project. So it's a really simple one. I created a simple main Go where we have just a string getting out, and to see a little bit of the injection of external values, I also created a variable, and the Go application. So when we say Go build, I hope it's visible for everybody. I will still create a little bit bigger. This one, strangely, you cannot scale. That's really bizarre. Okay, so let us run the application. And we expect now to get the build as unknown and the version as 000 dev. And yeah, absolute. That's what we expected. So hello, GopherCon Turkey, and the build is unknown. That's completely fine too here. And that's it. And if we want to go build the application, I just type it here with go build. Let me not put the LD flags in. And we should get now a binary here. In this case, I'm on a Mac OS system. So, and again, this one is also working perfectly. That's what we expected. So let us see, remove this one. Let us check now the makefile as a reference. So I created here really a basic makefile. So again, I defined here in my variables and everything here. I limited the platforms because I said, okay, here, and also the architectures. I didn't want now to make ARM and all this stuff because then we wait for ages. The binary name, the version, here the build version I will get from Git. So I put a Git command into it, and then here's also the LD flags, the dist folder. That's completely fine. Here, some good practices, having this command. So if somebody comes here and just type make, he will get all the available commands. That's really interesting. And then I have all the steps, for example, I want to do. So I have a clean step because I want to delete my dist folder. I have the build all, where I want to create all the what's the name? All the architecture version I defined on top of it. So you see it starts already here with some fancy loops going on, getting all the shell commands together. And cleaning, that's what we say. And again, it's cool, Hüseyin, props to you. Again, Golang CI linting. I want to get everything linted so I can execute also the linting part. And of course, I can create a Docker image too. So that's the thing. So I create the Docker. In this case, he takes the binary I created and I mean the Linux binary and puts them into the Docker file. So it's really not voluntarily not built to show you a multi-stage build, but to say, okay, I build it somehow, get the binary from the dist folder and put it into the Docker file. So that's completely fine. Okay, then let us create, I mean, we could put tests in and so on. So you can imagine you can really go crazy here with all the things you need for your project, checking out sub-projects and so on. So that's really fine. Let us create now, for example, the build all step. So we say make, I just copy paste this here, build all, and we see the dependency graph gets built up, and he should create everything for us. And let us see, is there a dist folder? Yeah, there is the dist folder, and we have also the different binaries for different platforms. So if we go and call now the GopherCon and the Linux one, not the Linux one, the Mac Arwin one, and you see now we get the same expression before, but here we get the git commit ID we get, and also the version we injected from outside and everything. This is to make it configurable, so that's completely fine. So let us start now with our first alternatives, and we started the presentation. We started with Mage. So we use the same approach, and we're going to use also Mage. So let me clean everything. Okay, so the dist folder is gone. And now we would like to start with Mage. I installed already the binary. There are different ways to install the binaries, and I'm always a fan to let you as a developer decide which way you prefer. So we have, I mean, I can talk again only from me and my experience in my company. We have persons who prefer to use Brew, other persons want to download the stuff. Then we have persons, for example, who use Arcade as a tool to download the binaries they would like to have because they have some specific way to save them. So it's again up to you. We are not talking about this, but if you want to use the Mage, we can just say mage init, and he will automatically create for me the mage file with some boilerplate code into it. So we get the annotation on top of it, and we already get our first imports. So that's completely fine. And as you can see, also the first targets displayed. That's also really, really fine here. Okay, so let me, so that's the way you can instantly start. Let me just quickly grab and go get the bibliothèque. So okay, so and then we can use the stuff. I created already, to not bore you too much, the version for this demo product. So I just translated the make file you just saw before. I translated it into now a mage file completely written in Go. And again, it's written in Go, and I'm sure everybody has a different approach to tackle the stuff. But for me, I will show you the way I did it here, for example. So as you can see, you can say, if I'm not entering a default target, he just should execute. I mean, if I don't say mage and then a target, for example, he should execute as a default always the build step. And then you see, I create here my variables. I say, okay, for which platforms I want to use this. You can organize this on a different way. You can create structs and put this stuff together, and so on and so on. I created my variables here as a constant, so the binary name, the LD flags. And here you see I'm going to use the formatting from Go, the version, and the dist folder. And then let us go now into the build step. That's the build all. Here's the build step. And here you can see with the helper library from Mage, I can use, I can create dependencies. I can say, please execute before you execute the build. Please execute the clean target. So the clean target, what he's doing, OS remove all, deleting the dist folder. That's everything we need. I mean, that's what we do in our daily work with Go. Perfectly fine. If we're going for the build step, so we say the clean gets executed, and that's completely fine. Okay, here I'm missing something, but that's good. So we can instantly. So we call also instant dependencies. So we say execute clean, please, and then install also the dependencies. And here install dependencies, for example, is not doing anything else than calling, for example, our Go mod tidy. That's also very fine. And at the end, my Go application gets built. Here in this case, for the specific architecture I'm on, so for my Mac OS, like the one we did before, and setting also some flags with the linker flag. So here with get build, you can see what I'm doing here now is I executing here a command for the Git to get the information, and giving the output of this as a return value for my for the formatting for the linker flag. Okay, so again, sorry that it's not zoomable in IntelliJ. So we can now say make mage and say build, for example. Okay, and then we execute it, and you see he's calling the installing dependencies. He's cleaning the dist folder just in case, and then he's building my application. So we should have again. Here in the dist folder, we have now the specific version like we had before. So I can say no dist, and we go GopherCon, and you see it's working completely fine. That's really cool. So let us go now for the build all step. All. Again, cleaning. Oh, I forgot to go mod. Okay, that's okay because he have it already. And now we see here that he created also the the different architectures I said, but as you can see, it's just a for loop. So that's something we already know. I mean, you can go completely crazy again, like you would do in your programming thing. So this is really a simple one, but I just iterated here over the different available platforms, or the platforms I would like to build, and he created it. And I just executed here the run command. This is the second helper library from task. So completely fine. And last but not least, let us see how he's creating a Docker file for us, or the Docker build. Here it's the Docker. Let me call Docker, but as you can guess, I'm just calling the command, and he should create for me now the stuff. Okay, you see my Docker engine gets kicked off. And if we run now Docker run GopherCon, we expect hopefully to run Docker run. Okay, looks like he collected a different version. Okay, I have to check this one. Never mind, but yeah, that's the thing. Last but not least, when we want to run, for example, the linting, again, you can put everything into a dependency and create different targets and so on. So that's completely fine. But as you can see, I can call also the linting stuff. And here you should see I get also error message, because, or not an error message, a warning that I could write it probably better than here. There's a simpler version to do this stuff. So that's completely fine. Okay, and yeah, that was the mage case. So as you see, I feel very familiar for him, especially because with the grunt, for example, from my front-end experience, I really like this, because here I feel myself at home, and I understood and don't need to come up with some fancy own ways of handling a loop, a condition or whatever, because this is the stuff I already use in my code. Okay. Let us go to the next use case. So let me delete again. Oh, this time I use mage. We say mage clean. Okay, and it's gone. Okay, now let us take a task file, for example. Again, with task, you install the CLI as you prefer. And then we have also here the possibility with task init. We can create here a task file. Yeah, it's without the A at the end. I created a ticket, so they call it YAML with a A, but here in this case, it's without the A. And you get also a starter definition of your task file. Again, I created also for this one an example. So this is the one translated the make file from our simple example. Again, as you can see, I can define, look, let me go up with this. I can create environmental variables. I can create variables, lists. I mean, everything is possible. I can even create variables where the content is dynamically. So here in this case, the build version, he executes a shell script for me. A shell command where I execute the git command, for example. And then, as you can see, I can put now the values, and everybody who used Go templating will like, wow, I noticed that's Go templating. Yeah, that's Go templating. You can use the Go template engine and just put the stuff in. Again, the variables here, the platforms I'm going to do. And similar to the other approaches, we create our clean tasks and we create our setup tasks, for example. And as you can see here, I can create, again, dependencies. I can say to him, hey, when I call the setup, please call the clean before. So I'm always sure to have a clean slate when I do something. I can create a description, and I can go here again, put everything underneath. I can call a task if I want to call a specific task, because a dependency can be possible that it's not executing in the right order. So if you want to be sure that the task gets called, for example, you can explicitly call a task. You don't need to rely maybe on a dependency because there's a racing condition going on and you want to eliminate this one. So again, here you have much to do. By the way, I'm using, as you can see, GitHub Autopilot. So that helps also quite a lot for creating this stuff. And here again, test linting. We already saw this. So linting depends on setup, and setup depends on clean. So you would expect later to see all the different steps going down. And here we have again the build. You see, I'm using the templates. I'm using the variables inside. The Dogger one is the same like before. I'm calling my Dogger build. I'm using the variables I defined before. Now, the build all is a little bit, what I said before in the beginning, is everything as easy, or is there some other things, the trade-offs, for example? And I found, for example, creating the multi-architecture build in this case, I used heavily the Go templating, creating also the range to iterate over the different platforms I am available. Yes, you see, it can get a little bit verbose also here in this case, but still everything is understandable. So that's completely fine for me. And here I see I built everything. So let me try a task. Let us use the, in this case, we still use here the task, and let us do the task build all. You see he cleans the dist folder. He creates here the go mod tidy. He's calling again to download the latest modules, and then he's executing the build. And we would expect again a dist folder. Yeah, absolutely fine. We have again our application, our binary inside, and we can call the GopherCon Darwin again. And as you can see, it has also the values injected in, because I defined them here again here with the short version, for example. Let us not use the short version to show that it's not something pre-built from the last time. And we call, and you see that's perfectly here. It's now the long version of the Git. That's fine here. And again, yeah, maybe I should show one part here. As you can see, the generate, for example, this task gets only executed when something changes. For example, he takes care. That's what I meant with the code generation, for example. You can completely jump over tasks because nothing changed, and you gain also here very quick speed, and everything is inbuilt again. So that's really, really nice. Yeah, let us also make the Docker build. So again, this is the Docker build for uploading the specific version. Let us see if it's now working. Docker run, probably not. Okay, yeah, this one is working. So he picked up the correct version from the dist folder, and I created again a Docker image or a container out of it. Here, it's everything written. So that's completely fine too. This is the task approach. Again, I will put in the slides, there are the links, and I will show them later on. Again, there's much more you can do. I mean, this is really the tip of the iceberg of the possibilities you have with task file, for example. So, and the next one is our Go releaser. So here again, let me, oops, delete, let me clean everything. So there is nothing then. You can again install the Go releaser CLI again the way you prefer. So nothing changed here. And we have again also an init command here. So when we type Go releaser init, he will create for us a Go releaser file with some starting points. And this starting YAML file is already mighty. I mean, you hardly need to change anything for executing it. That's really, really nice. And I just added again because we wanted to show the substitution. So here I created the substitution. There's only one thing. I've written my own Docker file for this. It's just because I did not want to modify the other one. Docker file, Go releaser. So So cancel this one and we take this one. It's just a minor thing and I didn't want to spend now too much time with changing the stuff. So let us see how the anatomy of the Go releaser file is. Again, here we have the project name. So here in this case is GopherCon Turkey 2021. You can change this again. I mean, if you don't add the project name, it takes a default from your folder name. So then it's similar. I just wanted to show that you can set this on different thing. I have here the possibility to execute so-called hooks, where I can say, okay, please always run following commands. In this case, I say, okay, I want always to get go more tidy. I want to run also the linting. Maybe there comes an exit value and I don't want that he's continuing his work. And then you see here the build tag, and here I can define everything what is important for me for my build. There are many defaults. You can see the documentation of the Go releaser page. There's much you can do and much to change from the architecture, from the ARM architecture. There's really everything thought about. Here again, what I said before, the operating systems, the architecture here on the AMD, on the 64 architecture, the LD flags, similar to the ones you saw before. Go releaser has an advantage. He has also many default values saved. So when you go on the documentation page, you will see plenty of default values or default variables you can just instantly use. For example, short commit. As you see, I did not need to enter some git whatever command. I can just say short commit, and he's putting the short commit already inside. And that's really comes handy because it reduces everything I write. And so I have no liability here because I don't need to maintain this code, and I'm not need to change this or have some maybe technical depths inside or some flaws inside. And then, as Hüseyin also mentioned, there are plenty of possibilities to customize this. For example, I can rename the archive files, what he's creating. I can zip them automatically. I can gzip them. There's everything inside. And here I say also, please create also a Docker file for me. And now comes the magic to execute this. So I can say Go releaser, release. Here in this case, I say to him, hey, create a snapshot, please. It's not a release version where he executes also the upload to the GitHub release page, for example, because I want to execute this locally. So I can say Go releaser, release snapshot, automatically release the dist folder. You see, I don't need to take care about the dist folder. And now hopefully it runs. Okay, now we have the Golang issue. So let me disable this. Don't do this in your real projects. And you see he's creating here now the stuff I would like to have. And also my Docker image gets created. So I can say now Docker run. And what is the image template here? It's GopherCon. So I can say, please execute this one. And you see, it's also giving me the short commit. Again, I did not have to use any git, whatever. I could execute. I can just use the predefined variables. The team from Go Releaser is providing me completely fine. And when we see what Go Releaser created for us, the dist folder and some additional meta informations. But again, I have also my binaries. I just did not put them into folders, or I zipped them because I just wanted to show you now the beauty of it. But again, everything is configurable. That's completely fine. Okay, so that's this place. And now, last but not least, to finish, to slowly wrap up the session, is going now to the multi-stage. And for this, I created here a multi-stage file. So let me get this also here in a file. So we say Docker file multi. I will commit this later into the Git repository, and if you are fancy, you can check this out. So here, last step, this again is a very simple one, and you can really go crazy. You can create also your own Docker tool containers where you bundle specific tools or CLIs into your main container for building, for example. So we have here the step randomly called builder. So I take here the Golang version, I take the Alpine version, and you see I say go mod tidy. I could also call the Golang CLI, for example, if I created another container on top of it with the Golang CLI inside, and could say, okay, please execute the Golang CLI. In this case, I did not do this. And you see again, I will build the application again. In this case, I know that my target, everything will be a Linux based, so I did not set any specific version for the architecture inside. If I wanted to create, for example, a multi-arch container, then I could also enter this information inside. That's no problem here. In this case, I know it's only running on a Linux system. It's a demo application. And here again, we see we can take now the artifacts created and just the artifacts, that's fine. He discards everything else. My image will be still slow. I use here, for example, the Alpine, but yeah, you could use also the Scratch, for example. And I get the output from the other container as an input for my next step. And then I just can continue. In this case, I will create a user because I don't want to run the stuff as root or whatever user, and take care that my application gets executed. And now there comes a thing where you say, okay, this is something, maybe you have to start to mix this because nobody can remember now this build command I put here inside. Let me put it here also to talk about this. So I call the Dogger build like in the other things. I say which file he should execute here, the container name or the image name. And here you can see I put the build args as a variable inside. But again, there's a different ways to handle this also. With env files you can work and so on. So everything is possible. But here, just to make a demo, and now I execute this, and he should build. You see, everything gets freshly built. Here in this case, sometimes he reuses the cache. That's also speed up my build process. You see, it really was a quick build process. The bigger your project, the more advantage you have from caching different layers, for example. And if we run now the XXX or the 6x container, we should now get also here hello GopherCon and the version. Okay, so that's all the possibilities. Let me look, we have 3 minutes left, so let me quickly go back to the slides. Okay, so demo is done. What's my conclusion? You don't need to use make. That's what I can say. So there are possibilities. There are good possibilities. There are worse possibilities. There are possibilities you need to see if they fit into your project, into your thing. But the message we started with to do make or not make, you don't need. You can use whatever fits to you and your skill set and your company. Okay, questions. Again, I will upload the slides. I don't know how we're going to donate or how people can get access to the slides if needed. I will upload also the demo project to the GitHub, so you can check it out there. And yeah, that's it. Do we have any questions in the chat?
Actually, I'm just looking at the chat, but I don't see any questions. But well, if anyone has any question, how they should reach out to you, Engin? I mean, they can, they can reach out to you on Twitter. So you can, I mean, I don't know, you can give your Twitter or any other channels that you want.
Yep, they can come. I'm on the Discord server, so actually in GoTurkey Discord server, you can find me there. I'm in different Slack channels. I'm also in the Slack channel of the Kubernetes, for example, so you can contact me there. On Twitter, I mean, this should be not a problem to contact me, and I'm always happy to help and also to deep dive if you have a question or you want to show something and need some more help. I'm really, really happy to help out as much as I can. As I said, I'm also not the 100% Go developer I would like to be, so that's fine. Yeah, that's it.
I see. Yep. Yep. Yeah, I don't see any questions. So thank you for your time and your presentation. Hopefully we see you next time again. Take care.
Okay,
Engin.
thanks a lot. Thanks for inviting and have a good day. Bye.
Bye. Okay, so our next speaker will be the Mert Coşkuner. Mert is working as a security engineer at Amazon, and he will be talking about Agile application security, Golang adaptation. So let's welcome Mert to stream. Hey Mert, how are you?
Hey guys, how about you? How are you? Hope you can hear me.
Yeah, we can hear you right now. We are totally excited for your talk. So if you share your screen, I can leave the stage to you.
Sure. So can you see it?
Yep, let me add to stream. Okay, that's perfect. So I don't want to take your time, so you can take it away. Good luck.
Thanks. So welcome everyone. I will be talking about application security, but in a Golang and developer edition. I just refined my previous talks regarding application security. So as I said, I'm Mert. I'm security engineer at Amazon. I'm dealing with application security problems day to day within Amazon PXT, People Tech Security team. Briefly, I will be talking about some definitions first, and after that, I will briefly talk through the secure coding practices that you can apply when you're coding and implementing your day-to-day solutions. And after that, I will show you a brief automation part that you can apply to your day-to-day code or CI in order to automate some of the coding practices that we will be talking about. So in the definitions, I will first mention application security, after that threat modeling, SAST, and OWASP. So basically, application security for us is the measures that we're taking while we're developing or implementing our application. So basically, it drills down to the finding, fixing, and preventing security vulnerabilities all around the software development lifecycle. So it basically begins with requirement analysis and never ends. So while you're starting with requirement analysis in the lifecycle, if you don't know about the security or potential risks, threats that you're going to be having, you can always check some referential documents. And at that point, I would recommend OWASP. It's an open source initiative to raise awareness about application security overall, and they're having OWASP Top 10, and which nearly updated, and you can refer that document to learn about or having to know risks and potential threats for your applications. And the OWASP Top 10 lists the 10 most criticals for the web application security. So by knowing the risks and potential threats in the security scene for your application, you can actually, starting from the requirement gathering and use case through the development cycles, you can model your threats for your application. So it's basically a procedure that you're identifying your potential risks and threats for your use cases, and you're enumerating these threats and come up with a potential security controls so that you can make sure that you're prioritizing your risks accordingly so that you can implement them in your code. So having the threat model in your design makes your life much more easier, because when you're implementing or maintaining your application, you can always go back and see your threat modeling, and you can just check your potential threats and risks that you're addressed or not addressed, but documented over the threat modeling. So as I said, you will have your use cases and potential threats in the lifecycle. But when you're going to implement your use cases or the design into the code, you may or may not have addressed all of them, because you may not know all the risks or all of the potential secure implementations. So for that, we have static application security testing. It's shortened as SAST. So it basically examines your code to find vulnerabilities. It's much like similar to the Q&A testing, but for security purposes, you can think like that. So by performing SAST or static application testing in your code early and often, enables you to have at least minimal amount of vulnerabilities in your code while you're implementing your application. So at the automation part, I will mention how can you achieve it for a project. So let's talk about secure coding practices and review common mistakes that developers are doing and their common mitigations that you can apply to your code. So first, I'd like to begin with input validation. So wherever you're getting a user input, there lies a potential security risk because you cannot rely on users' ability to input something that is secure all the time, because there's lots of threat actors, bad users, or malicious ones that want to leverage your application on their behalf. So one of the common mitigations for validating the input is the whitelisting. Maybe you can whitelist the inputs that you're expecting from the user, escaping that you're getting the user input, but you're just escape some characters that may have potential security risks, such as these less than or bigger than characters that's commonly used for script tags, for example. So you can also check the boundaries and validations for the input. For example, if you're waiting for a string input, there's no reason for you to not checking that input is actually a string or numerical value or not, for example. And lastly, make sure that you're stripping all tags in your input in the inputs that you're getting if you don't need them. There's a couple of libraries that already implement those validation and sanitization actions for Go, and you can use them for the input sanitization in your code. However, input validation alone isn't enough for the application to be secure in terms of the getting user input. You have to also encode your outputs, because since your inputs can cascade into the other apps or microservices and come back to you, it's important for you to have server-side input validation as well. That's what we are calling output encoding. So one of the examples in Go, for example, there is the parameter request. There's the HTTP request that gets in the parameter, and by default, when you're saying test, it just gets content type as plain text. But if you're inputting tags, it turns into the HTML, which is not good for us, because you can just have these kind of parameter inputs from the user and run JavaScript into the application. So for this, allowing certain content types is not enough, although it's some kind of mitigation. What you can do, for example, is using HTML template, so that you can template the inputs and the parse accordingly. And when you're using HTML template, for example, in the code, it's going to sanitize and strip all the tags. And as you can see, the input type is still, content type is still the plain text. And the other common mistakes is the SQL queries. So there is a select statement over there which concatenates this customer ID over there. So the problem for that is when you run the query, since you're concatenating it, what happens if I just input 1 or 1 equals 1? So it's going to turn all of the rows from the credit cards, for example. So for this, we're using prepared statements to mitigate it. So you're building your query and make it as a statement, so it doesn't have to it does not get malicious input like that within the string concatenation, for example. So authentication. So of course that all of our applications, one way or another, have authentication. So in its essence, it's a way for us to identify our users in a way. So for the authentication, it must be sent to an encrypted connection via post method. That's the method would be post, because if you're using GET requests, these tokens or whatever you're using for authenticating a user will going to be sent through URLs. So by sending it through URL, you're exposing your tokens or authentication method or authentication token within there's the risk of exposure these tokens within the logs or within some kind of traffics. For example, when you're going into the common networks like Starbucks or at the airport, you can you may use common Wi-Fi's, and by sending these authentication fragments through GET methods may expose these into the common networks. And on top of that, don't forget to log your every successful or unsuccessful attempts with the date timestamp, because you're going to need it to detect if there is any problem with these authentication solutions. So ideally, you will have form with post method and autocomplete off. And also, you're going to ideally have CSRF value tokens. These tokens make sure that these forms are sent on its own, and you're going to identify these forms with these tokens so that you can prevent request forgery by using these forms. For example, if I were to embed this form to another page, and if a user who's authenticated to your website and browsing the internet may visit my website, and I can send this form on behalf of this user. So having a CSRF token would prevent these kind of incidents and for attackers to send requests on behalf of your users. And always make sure that when you're replying back to the user with an errors, you don't make your errors specific. For example, if your user gives your input wrong password, just say invalid username and or password, not invalid password, because that would enable attackers to enumerate passwords or potential usernames or mails or phone numbers, that whatever you're using to authenticate your users, to be enumerated by attackers just because you're giving the information that this user is on your database, but the password is wrong. So for the authentication, I would suggest checking out the hashing algorithms that OWASP is suggesting, because when you get the password from the user, you're going to hash them, but hashing them with a strong hashing algorithm is always good, because when you're in a case of your database or the passwords are compromised, they can be brute forced and cracked, and the passwords may expose. So that's why you're going to need strong hashing algorithms. So the examples of the common ones are the bcrypt, PDF key 2, Argon 2, and scrypt. Depending on your performance needs, you can use either of them. And never implement your own cryptography algorithm, and make sure that you're using whatever is accepted and generally used. Implementing your own crypto algorithm or implementing, for example, implementing bcrypt on your own is never a good idea, just because there is a vast amount of libraries or vast amount of frameworks that's already used commonly, tested by all of the community. So they less likely to have some kind of vulnerabilities or misimplementation that you may potentially do while you're implementing your own crypto. And just make sure that hashing a password is not in itself is not enough. So you need to salt your hashes. So the salting would be you're having the hash and you're just generating a random integers or values so that you can concatenate these random values with the hash that you generated for your password, and that make your password password hash more long and hard to predict or crack. And I recommend re-authenticate your users before performing critical actions, so that you can make sure that the users know what they're doing and the users is the actual ones. And implement multi-factor authentication whenever necessary for it. For example, when you're doing banking transactions or updating some information that's critical or sensitive to users, you can always ask for another way of authenticating the user other than the username password. That could be SMS, that could be some kind of token or Google Authenticator, these kind of two-factor authentication solutions. But make sure that implement those for sensitive actions for your users. And always monitor these kind of authentication attempts, whether it's successful or not, because they can be utilized the same password for multiple user accounts to try to compromise the users, compromise your users for your application. For example, there is an attack called credential stuffing. So it basically collects the username password combinations that's on the internet and that's already exposed. And by having these usernames, mails, and the passwords, these attackers can try these in your website. So if you're monitoring those authentications, you can identify whether you're being attacked by some kind of attacker using some kind of combo list of mails and passwords, so that you can remediate these attacks accordingly. So again, we talked about hashing and salting, etc. And as I said, neural crypto, Go already has crypto library. So for example, you can use bcrypt to hash the password and insert it into the database. And after that, you can use again compare hash and password function from bcrypt to check if user input user password is actually the one that you're having in your database. And once we authenticate the user, we're going to need to manage this session, of course. So for that, I recommend generating a session identifier that's strong enough to not forged or brute force identified by using brute force solutions. So for this, you can just generate JWT token, JWT signed token, signed with a secret, so that it cannot be forged for someone else. Having your cookie HTTP only secure flags in the cookie enables you to send these if you're having this token into the cookie, enables you to send your cookies securely for your sessions. And again, never use your old sessions. Just make sure that your users have a new session every time they're visiting your website or application, and never expose these identifiers in URLs. So that it comes back to the first authentication form that we discussed. If you're sending these through GET requests and in URLs, it's going to be exposed one way or another, whether it's on the network or in the logs. Somewhere it's going to be exposed, and you never want these tokens or keys to be exposed, because when it's stolen, it can be used by someone else. So we are having, we authenticated the user, we manage the session, so there comes the access control then. For this, we talked about JWT token, but it can be other kinds of parameters or methods that you can use to manage access for the user, but make sure that it's a single one, so that you can have one solution for your access authorization, and you're using it for all your sub domains or sub components of your applications, and enforce them in every request that's necessary for a user action. And these access controls should fit securely. For example, if I were to visit my profile, if there's any problem for it regarding access control or another way, I should not be able to visit my profile and see my information. So it should fit securely. You can use a defer feature to achieve this, and always make sure that you don't leak information while failing. So also the other thing that you need to make sure is that your front end or your application backend or server side should have the same access control rules all over the place. So not only you need to have a single access authorization mechanism used site-wide, you also need to apply this site-wide mechanism also in your backend as well, so that you have one integral access authorization rule or controls. So in any case that you're not using JWT, for example, when we're having JWT, we have signed token, signed with you using secret, for example, in the other example. So if you were to use other mechanism other than the JWT, and if you need to store this on client side, for example, make sure that you're using encryption for this, and always perform integrity check for it, because it can be tampered. For example, if you're using some kind of value in the cookie and you're storing it into the browser's session or some other place on the client side, if you don't encrypt it, user can tinker with it. And if you don't check the integrity, user can just change the value or change itself to be another user to impersonate, for example, and you may put your users at risk just because you didn't enforce encryption and integrity check to these control tokens. So again, never implement your own crypto. Always use whatever is already in public and widely used, so that you can avoid making mistakes for crypto. Also monitor your vulnerabilities. Monitor vulnerabilities in the packages or modules that you're using, so that you can always make sure that your modules are 100% updated and vulnerability free. For example, just last week there was a critical vulnerability that Log4j has. For example, look for these kind of vulnerabilities by using, for example, dependency track kind of open source tools, so that you can make sure that your modules are safe. And if you're using containers, please make sure that you minimize your containers. By minimizing, I mean that your containers only have modules or the environment that your code needs in order to run, not the other fragments, packages, or functionality whatsoever. So you can achieve this, for example, by using Minikon. And after that, make sure that you're scanning your containers using, for example, Tree, to make sure that your containers is updated and secure against the vulnerabilities that's known for containers. So we talked about lots of things. For example, we talked about input validation, output encoding, SQL injection, authentication related vulnerabilities, which can born from cryptographic issues. So how do we integrate automation to our pipeline or to our day-to-day coding activities so that we can make sure that at least the nuance can be ruled out with automation while we're developing the application. So the process I will introduce is the commit-based scan. You're going to write your code and commit. While committing, you're going to scan. So you're going to perform static scan. So for this, you can employ pre-commit scripts and SemGrep scanner. SemGrep is the open source static application scanner that has community-driven rules that you can use for your applications depending on your language. So for example, if you visit semgrep.dev/r, there's a bunch of rule sets that community is developing, and they are updated pretty regularly. So there's also rule sets that covers Go. And by setting up pre-commit hooks and configs, and these sample hooks and configs you can find on SemGrep's GitHub. By setting up these pre-commit configurations, whenever you're committing, SemGrep can run the rule set that's needed for your application and list potential vulnerabilities or the risks that you have in your code. So by setting this mechanism in the CI pipeline to run pre-commit hooks whenever a pull request is made, and by disabling the direct writing to the main branch, you can make sure that every commit is scanned by SemGrep, or you can say every commit is scanned by static scanner according to the rule that you're implementing your code, so that you can make sure at least the rule set covers the vulnerabilities that's widely exploited or widely widely mistaken by the developers. So thank you for listening to me. If you have any questions, I can answer them. But or you can always reach out to me via LinkedIn to ask questions afterwards.
Okay, I think that was a great presentation, Mert. So I'm just looking if there is any questions, but I don't see actually any question. And also we have actually out of time. So like you said, if you want to reach out to Mert, you just go to his LinkedIn, or he also has a Medium blog. So you can check that one as well. So thank you, Mert, for your time and your presentation. Hopefully we see you next time again.
Thank you. Cheers.
Okay. Thank you. Take care. Okay, so we are coming to the end of today's presentations. Now I want to welcome our next and last speaker. So our next speaker is Sertaç Özercan. Sertaç is working as a principal software engineer lead at Microsoft, and he will be talking about strengthening supply chain security by using OPA Gatekeeper on Kubernetes. So let's welcome him. Hi, Sertaç.
Hello, everyone.
So,
let me figure out the team yard and how to present something.
Okay, so you can share your screen. Okay, I see you right now. So I'm just adding it into stream.
Cool.
Okay, I think it is ready. So I don't want to take your time. So you can take it away if you are ready.
Sounds good. I'll get started.
Okay,
hello, everyone. Welcome to my session. So in this session, we're going to talk about how to use Open Policy Agent, OPA for short, Gatekeeper, and then it can be used to strengthen your supply chain security. Like Safa introduced me, my name is Sertaç Özercan. I'm a principal software engineer lead in the Azure Core Upstream team at Microsoft and a maintainer in the OPA Gatekeeper project. So in this presentation, we're going to start with what is Gatekeeper, who's Gatekeeper for, And then we're going to talk about Gatekeeper's core features. We're going to look at brief architecture. And at the end, we're going to see some exciting demos. Okay. Thank you. First, what is Gatekeeper? Gatekeeper is a customizable Kubernetes admission and mutation webhook that helps enforce policies and strengthens governance. Gatekeeper enforces policies through open policy engine. And OPA is a policy engine for cloud-native environments in a CNCF graduated project. And then in this presentation, let's see how you can leverage it to extend supply chain security and governance in your Kubernetes cluster. If your organization has been operating Kubernetes, you've probably been looking for ways to control what end users can do on the cluster and ways to help ensure the clusters are in conformance with company policies. And these policies may be there to meet governance or legal requirements or to enforce best practices and organizational conventions. And then after talking to customers, we heard that admins would like to automate audit and enforcement of policies to free up their time while defining common best practices across the organization. On the other hand, developers would like to be able to self-service deployments of their applications and fail fast with actionable feedback and items if something is not compliant. And as you can see, policy is a team effort, and Gatekeeper was built with this philosophy in mind. Separating these roles into discrete areas allows for specialization where work in each area benefits the other and increases its scale. So let's talk about a few personas. First of all, the policy authors. The policy authors would like to figure out how to implement common generic checks. For example, they would like to be able to restrict labels on Kubernetes resources, but they don't care about which resources or which labels or how this gets enforced. And then for cluster admins, they want to figure out what checks they want to use. For example, they may want to restrict the owner label for objects in the prod namespace. So they can figure out who the owner of an object in the prod namespace is. And then last but not least, developers would like to figure out how to deploy their applications. And in this case, they want to deploy their service in staging in production, and they want to fail fast if something is not compliant and have a quick turnaround with actionable feedback and in messages. So let's talk about Gatekeeper's core features. So Gatekeeper comes with a validating admission control to validate Kubernetes resources. So this controls what end users can do on the cluster. And in a mutating admission control that is currently in beta right now to alter resources as they are being created. For comparing resources like uniqueness, you can use referential policies using OPA cache. And policies are defined via a query language called Rego and can be parameterized and configured. And we also provide a community-developed policy library that contains general policies as well as alternatives to pod security policies, including mutation. In external data, which we're going to talk a lot more about in this presentation, enables Gatekeeper to interface with external data sources. Right now, it is in the alpha stage for validation, and it is in development for mutation. And then it kind of ties in with the OPA's custom built-in functions that's written in Go. We're going to also talk about that, how you can take a Rego that's query language for OPA and then have a bridge to execute Go in there. And then, so this basically allows for extending the Rego language using Go. Cool. And then continuing with the core features, audit. Audit will periodically check the cluster for non-compliant resources and provide a report. Dry run. And then dry run will deploy policies without enforcement. So you can gain confidence before rolling out a policy, so you don't block users without actually trying out first. Namespace exclusion. And you can use namespace exclusion for excluding certain namespaces, like kube system, for example, from validation or audit or mutation, any of these operations. And we also provide metrics for policies, for violations, for both validating webhook and then mutating webhook, and audit and resource sync if you're using the OPA cache. And finally, multi-pod deployment of the validating and webhook pods for high availability support. Cool. So let's talk more about the external data. All right. And in this case, it is similar to OPA's built-in HTTP send functionality, as in it can basically use for sending HTTP queries to anywhere, basically, right? However, we thought there were limitations to this approach. First of all, Gatekeeper's mutation functionality does not support Rego, and then obviously then it cannot use OPA's HTTP send built-in functionality, as we want to also extend external data to mutation. We also thought there were security concerns due to a multiple number of factors. So first of all, if the template authors are not trusted, it will potentially give them access to the in-cluster network. Say, for example, let's talk about like the log4j vulnerability. If the template author is not trusted, they could potentially send a request to an in-cluster pod exploiting that pod's weaknesses, even though that pod may not be exposed anywhere else. And then if template authors are trusted, authors will need to be careful on how Rego is written to avoid injection attacks. Cool. And then let's talk about the external data benefits. So first of all, it addresses the security concerns by restricting which hosts a user can access. And then we're going to see how we can deploy provider objects on limiting this behavior. And it also provides an interface for making requests, and then which allows Gatekeeper to better handle things like escaping strings. Another big advantage is it provides a provider-based model for common interface for extending Gatekeeper with external data. So all the providers can use sort of the same guidelines and standards instead of each of them kind of doing their own thing. And then this will also benefit on performance optimizations, because we can now directly control caching, and then which values are significant for caching, and then that will increase the likelihood of cache hits, which will increase the performance and decrease any potential timeouts. Okay, so let's talk about some use cases. So in this presentation, we're going to look into more on the validation use cases. So first of all, it's image signing. So checking whether an image is signed, for example, with a cosigned signatures or Notary-V2 signatures. Checking if an image has an attestation, for example, in total attestation is attached to the image, for example. Checking image vulnerabilities. This can be done with a scanners like Trivi, Gripe, or any other ones. So when you deploy a potentially vulnerable container, you get alerted right away that, hey, here is like there's like 5 critical vulnerabilities, for example, which we are going to see in the demo later on. Software below materials, SBOM validation, which is, and then you can think about, if you're not familiar with SBOMs, you can think about that as like a sort of food ingredients, basically, right? Like nutrition facts of a software. And then checking whether an image has an SBOM in the first place, or whether that SBOM contains certain licenses, or maybe not contain certain licenses also, maybe your organization does not approve, or certain dependencies also, like a specific version of it. So again, coming from like the log4j, you could check for like a, hey, that is that specific version of this library is in my code, or has been used for building my code. And then talking about some of the mutation examples, a tag to digest, for mutating an image tag to a digest. So for pinning a tag, an image tag to a specific SHA. So it even though if the tag can be mutated later on, that the digest won't be mutated, so you'll know what you're pulling and what you're getting in your cluster. In another example of a mutation that I didn't cover, that's not particularly important for the supply chain security, maybe, is Active Directory integration. For example, adding labels or annotations for adding owners, such as your organizational team, like deploying a pod or like a config map or something like that, and automatically getting that resource mutated with owner as with your team. So if somebody is looking at it, they'll automatically know, hey, this team created this resource. Okay, so let's break down the ingredients and look at the architecture of Gatekeeper. Oh, I just changed the slide, but looks like Google slide did not get updated. So I will go through this one a little bit. Okay, cool. So this one is basically showing the external data feature. So first of all, Gatekeeper supports both audit time and admission time checks. And then this diagram is a high level of how Gatekeeper serves admission requests. And then if you don't look at the external data and data provider and the external data source on the right side, and then just on those other 3 blocks, those will be like the static validation. And then when something makes a request to the API server, for example, making like a kubectl request, the API server receives that request and then sends an admission request to Gatekeeper's validating repo. So it's asking Gatekeeper, hey, should I allow this request to proceed, right? And then Gatekeeper must answer this yes or no, and then the API server can take an action, right? And then, but to do this, to say yes or no from Gatekeeper, Gatekeeper consults its policy configuration, and then this is this larger box. Whoops. Larger box at the bottom of the slide. In the green object labeled constraint, it tells the admin what checks they want to perform. And in this case, for example, require image signatures or require image SBOMs. And then constraints rely on templates. And in the template is the blue object to tell the system exactly how to perform the check. So that's basically where the code gets written, right? So in this case, check if that deployment or this pod specs image is signed, right? However, like I said, this is specifically for external data. For regular resources, say you're deploying a config map, this admission request is already provided this request is already provided in the admission request. So you can see, hey, I want to check if this config map has this label, right? But in our case, in this example, it is a completely external thing that, hey, this is this image signed, which in the source of truth is in an external data store, such as a container registry, right? And then, so the way that, my notes, yeah, so since image signatures are stored externally, we need to check the data sources to validate whether they're signed or not through the Gatekeeper external data. And then the data returned back to the Gatekeeper through external data should contain information for Gatekeeper to say yes or no regarding the admission request coming from the Kubernetes API server. Okay, so this is where we define the URL of the provider. So in this case, we are going to use in this example, we're going to use the cosign provider. And in this case, it's an in-cluster service, and then there's like an in-cluster deployment. So the URL is the link to the in-cluster service, which then points to the in-cluster pods. And then here we have a constraint template example that sends an external data request to a provider. So in the green box, we have the Rego rules executed against an admission request and returns a violation from the response of the external data provider. Images, and then you can see so after it says build a list of keys containing images. There are a list of batched images from pods container images. So we can send a single request to improve performance and reliability. And then the way that the provider basically works is it basically references to the provider object we just defined called cosign Gatekeeper provider, right? And then it basically sends the images as part of keys, right? And then this is the part that I was mentioning earlier that that we are extending OPA's query language called Rego, which is in this case this one, with Go code. So in this case, external data is a custom function that we added. In this case, when a user does an external data call, it translates this into an internal API request that is built with Go. And then this will be sent through the to the external data provider. And then when the external data provider sends back the data response, it will go into this response object. And then depending on how that Rego is constructed, it could say invalid response or whatever the code wants it to do, right? Cool. And then next piece is the constraint that we want to apply for our constraint templates. So here we have the constraint of the kind Kate's external data cosign as defined from the constraint template in the previous slide. And then here, an admin can define the scope of enforcement and only apply this. So this one says basically only apply this rule against the Kubernetes deployment kind in the apps API group and in the default namespace. We don't have parameters in this example, but a cluster admin can also pass in parameters in a constraint to the constraint template. So you can also use parameters as certain values. So it could be regex, for example. So for example, if you wanted to say, hey, I only want to allow images from my private registry, so which is like a kind of a static validation, but you can have like a regex there that can say, and then that private registry can change like anything within your company's domain, for example. Okay. So let's look at a demo. So I'm going to share a video. Hopefully this will work. So would you be able to get the video?
Are you uploading the video right now, or?
I just shared the video in this StreamYard.
Okay, I'm just looking right now, but I actually don't see any video right now. Let's have a look. So there is a share and the video file. Did you click on it?
Yeah,
or?
I did a share and then the video file, and then I clicked on the video. I can see it on my side, but I'm not sure if it's
Okay, wait. Yeah, I think I saw it. Wait a second. So I'm just adding to stream right now.
Cool. Yeah. Okay. So yeah. Thank you. So in this case, we're going to start by creating a Kubernetes cluster using kind. So there's no like a magic involved behind the curtain. So this is like a generic kind Kubernetes cluster using Kubernetes 1.23 called demo. So it's going to take a second to start. Almost there. Okay, cool. So, and then let's do a get pods with all namespaces and basically nothing else running in our kind cluster. It's pretty much vanilla. And then now we are going to install Gatekeeper through the Helm chart. This is the version 3.7.0 of Gatekeeper with external data enabled. And we're going to deploy into the Gatekeeper namespace. Excuse me. Okay, so and then it's going to start the Helm deployment. It should take a second to deploy. Cool. So now we have our Gatekeeper installation in the cluster. And as you can see, we have the Gatekeeper controller manager pods, which control the mutation and validation piece, and then the Gatekeeper audit deployment, which does the periodical audit checks, as we mentioned earlier, and then it will audit all Kubernetes resources periodically. And then we are going to go ahead and deploy the cosign Gatekeeper provider, and then this provider comes with its own namespace, deployment, and a service. And then we are also deploying the provider. And I'm just going to print up the provider as we just saw earlier. And then here is the constraint template we just looked at that we're doing the external data request and then getting result back. And depending on, hey, this is signed or not signed, we are going to say invalid response and then why it's invalid, for example. And then here is our constraint. So again, like I mentioned, we are applying to deployment in the apps group and then the default namespace. And then what's also another interesting thing is the enforcement action. The deny is the default behavior. So if a resource is in violation, it will block that deployment with an error, right? So that's one of the things that we want. The other thing that we talked about was dry run. So then dry run will let the resource go through, even if it's violating. But as part of the audit, it will be caught. So it will be in the audit results. So even if it's in violation, it will be part of the audit results. And then the last enforcement action is warn. So it is similar to dry run. But it will provide a warning similar to the deny message, but instead of being a deny, it is a warning. So it will still the request will still go through. It will be admitted, and it will be in part of the audit too. But you'll get a warning as part of the kubectl command. So, and then the first example, we're gonna look at the deployment that we think that is going to error out. So in this case, we're gonna deploy I don't know if you can see it, maybe. I will just read it, gone through. Okay, cool. So yeah, we're gonna deploy an Nginx pod, which is obviously not signed in this case. So in this case, the error, I cannot see it because I am, okay. Yeah, it'll say verify my signatures, no matching signatures. So, and I think behind the scenes is basically going to the cosign's full CO ledger and then checking, hey, does Nginx have a signature? And the response is getting it's, no, I don't see this one. So the gatekeeper goes ahead and then, oh, okay, I don't want this. So I'm just going to block this. So cool. So let's look at a good example. So in this case, we're going to look into the gcr.io distroless static container, which is it is signed with cosign. So and then we applied it, so it went through. So again, like mentioned, it's going to go to the check the image signature. Hey, I found the signature, so I'm just gonna. And then the gatekeeper responded yes to the API server. So and then the request went through. So in our second example, we're going to look at a image scanning example. So in this case, we're going to look into Trivy. So I'm just going to deploy the Trivy server using Helm. Okay, and then that went through fast. Cool. And then let's look at an example Trivy provider. So I'm going to deploy the manifest again. It's very similar to the previous example. And we have the Trivy provider and the Trivy provider object. And then the template. And this is a little different, basically. But in a similar in the logic, if the response is saying, hey, if the result is more than 0, in this case, this returns a number of vulnerabilities. So if it's more than 0, hey, I'm going to say image, like something contains this much vulnerabilities. So again, similarly, we're going to deploy our template and constraint. These are all the same. And after we deploy our constraint, we are going to look into a vulnerable example. So in this case, we are going to look at an Alpine container. This one has some vulnerabilities. So this is Alpine 314. And then we're going to deploy this in a second, I think. Hopefully I get that one. Cool. Yep. So we are going to get that one. And as you can see, maybe I'll just go through this one so you can see it. Yeah, as you can see in the middle here, that we got 2 error messages in this time, right? Because in Gatekeeper, the constraint templates are ended together. So if an image has no signatures and has vulnerabilities, it will get both of the error messages. So in this case, it'll say, hey, there's no matching signatures, and this image contains 27 vulnerabilities, right? And then because it violates both of their both of the policies, we got both of the messages. So if any of them got a violation, it'll be in here. But if any of the constraints, for example, was dry run or warn, we would get like a block and a warning message, right? Or if it was dry run, it would just be admitted. So depending on how you would configure the constraints. Cool. And then in the last example, we are going to look at the not vulnerable. Again, we are going to look into the distro static, because this is like a known container for both that not vulnerable and signed. So because it provides both checks, which is convenient, it goes through. So that is the end of our demo. Saha, do you mind going back to the slides? Thank you. Yeah, and then I provided the examples here that we just talked about. So cosign validation for signatures. Thanks to developer guy for building that example. In the ratify validation example for validating Notary V2 and cosign signatures and SBOMs. And any feedback is welcome. Please come join us. Give us feedback, open issues on GitHub. Come talk to us in our Slack channels, and then join us in the community calls. It's at Wednesdays, 9 a.m. Pacific Standard Time, which might work better for Turkey. And then also 2 p.m. Pacific Standard Time. So we skip 1 week. So one week is 9 a.m. Pacific Standard Time, and then the next week is 2 p.m. Pacific Standard Time. Please come join us.
Okay, that was definitely a great presentation, Sertaç. So thank you so much for that presentation. I'm just looking at me. I'm just looking at the comments right now, and I actually don't see any questions. But if anyone has question, so how they should reach out to you? I mean, for the Slack, or if there is anything.
Yes, Slack is great. Yeah, my alias is S in my last name, Özercan. So you can reach out on Slack, or you can, if you have any issues specifically for Gatekeeper or OPA, you can also file issues. But yeah, Slack is a great way to reach to me.
Perfect. So thank you, Sertaç, for your time and your presentation. Hopefully see you next time again. So thank you. Bye. Okay. So yeah, we come to the end of our presentations today. So before signing off, we would like to thank you all today's speakers and sponsors, and also the audience for being with us here all today. And we enjoyed actually so much. Hopefully you guys enjoyed same as us. And Turkish session is still streaming right now, so you can check that one as well. And don't forget to check out the tomorrow's workshops. And like I said in the beginning, workshops links are available on GoTurkey community page. And so yeah, thanks everyone again, and we're really looking forward to seeing you all tomorrow and also next year's GopherCon as well. Until then, see you and take care.